Good morning, everybody. It is currently just before 9 a.m. here on the east coast of Australia. If you are just tuning in, you're watching our ROV pilots do a white balance on the camera. So this is Schmidt Ocean Institute's research vessel Falkor and ROV SuBastian. We are just getting set up on the seafloor, and we thank you for joining us. I am going to be joined this morning by Dr. Robin Beeman. He is our chief scientist, and he is currently sitting in his home in Cairns, so he will be narrating today's dive from there. My name is Deborah Smith. I'm a marine technician here on Falkor. I'm joined in the control room by Ben, Russ, and Chris, who are part of the ROV team. Russ is currently flying the vehicle, and Chris is currently working the arm to do a white balance with the camera. So we are just getting started, and we thank you for joining us. Today's dive will go to about 3 o'clock this afternoon, local time. And Dr. Beeman, are you there?
Yes, Debs, can you hear me? Testing 1, 2, 3, 3, 2, 1.
Got you loud and cleared.
Good morning, everybody, from the bottom of the Coral Sea. Through the day, I hope to be joined by some of the other principal investigators, PIs. We have an interesting group involved with this expedition, which is visualising the Coral Sea Marine Park. Today, we'll be working our way up what is known as South Flinders Reef. It's a beautiful atoll, several kilometres long. I'll give you some more accurate dimensions shortly, but it's the vessel, the Falkor, has been mapping here for the last 2 days, and we've got a very nice three-dimensional picture of the seafloor building up, particularly overnight. It's been the quiet hours, and the vessel's been doing some really great work mapping these steep flanks. And as part of that mapping, we found what looked to be a very large scarp feature. Scarp being the remains of an undersea landslide. And so today we decided we'd start a dive depth of around 1,000 metres, so 1 kilometre deep. And the idea is to work our way up the steep flank of the South Flinders Reef, essentially following the edge of where this landslide appeared. And it's left behind a fairly steep scarp face. Now that's ahead of us through the dive, and we're at the very bottom of the very base of this large reef. It's fairly sandy by the looks of things, but hopefully we'll start seeing something a little more different as we get closer to that scarp face. So thanks, Debs. She's just brought up the three-dimensional view. This is in Google Earth. So this it's almost bathtub-shaped coral atoll. It's about 16 kilometres along its longest breadth and about 6 kilometres across its shortest across its width. And it's sitting on a pedestal about 1,000 metres high on the deepest side. And you can see this right in the middle, this what almost looks like a big crack. And this is the left side, looking towards the reef, this is the left side of the remains of an undersea landslide. We're actually going up the right-hand side. We have distance limits with the ROV. We're trying to maintain a dive horizontal distance of no more than 2 kilometres. So about where that cursor is, we're at the base of that. And on the right-hand side, just above us, probably around about 800 metres depth, is the right-hand scarp of this undersea landslide. And so this landslide feature is quite broad in itself. It's probably about, it's at least 3 kilometres across. And so the idea is that we hope to find that it's where that strata is exposed from the landslide, it'll be hard rock features, and we found that it's a great place for marine life to attach to the rocks. And it's also really useful for us as geologists to understand the various rock strata that have created it. So some comments about the social distancing. Yes, you're right in some ways. This whole voyage is being run without a science crew on board because of the COVID crisis. There were all kinds of difficulties at the start of this voyage. I'm in Cairns, Australia. That's approximately, just bear with me a moment, I'm just doing some measurements. In distance, that is around about 300 kilometres to the northwest of where this dive is taking place. Myself and the other principal investigators are all scattered around Australia. We have Dr. Tom Bridge in Townsville, Dr. Merrick Eakins in Brisbane, Jodie Webster at University of Sydney, and Dr. Brendan Brooke in Canberra. All very interested PIs doing work out in the Coral Sea, but none of us were in a position to actually go on board the Falkor when it departed from Cairns. So this whole voyage has been planned and has been conducted with our science crew, but we're reliant along the very capable ship's crew who are doing this magnificent mapping work and working the SuBastian ROV. So Debs has just put up another 3D picture of our model here. You can see this blue line. This is the planned track, and we are working our way up to the base of this scarp. So we're looking directly at the scarp. It's around about 100 metres high, 50, 100 metres high. Oh, looks like the squid has just swim past us. Sorry, I didn't get a good look at that squid, but they're certainly amazing animals. We've already done 3 dives on the Coral Sea Plateau. There were two dives up at Osprey Reef at the very northwest end of Queensland Plateau. We did one at Holmes Reef a few days ago, and we've seen cephalopods at all of them, squid, octopus, and chambered nautilus. So it's really great to see another squid here at 1,000 metres depth. Right, can everyone see this big isopod over here on the west side of on the left-hand side of the screen? My screen's starting to, it's not flowing so well, so it's a little hard for me to keep up, but just got a glimpse of it.
Hey everybody, just going to say a quick hi to those friends and family watching in Rhode Island at home for me. Hi Julie and gang. There's a question on Facebook, how do we stream from the middle of the sea? Well, we have two very large VSAT satellite dishes, and they allow us to, we have two to prevent any shadowing, and they allow us to send this stream out to YouTube and Facebook. So it's really great technology, and it brings live ROV video image to you at home. All right. right, and happy Mother's Day for those of you in the U.S. It's still Saturday, but happy early Mother's Day. It's Sunday already in Australia. I'm getting a confirmation from somebody in the control room that it was a squat lobster that we went by, for those of you questioning that. And we have a very nice fish coming into view here. Jimbo, push the fish button for Glenn. Hi Barbara, thanks for joining us today. It's very nice to see some friends from home coming in and saying hi. Good morning, everybody. Thank you for joining us. If you're just joining us, this is Schmidt Ocean Institute's research vessel Falkor in ROV SuBastian. We are currently diving on South Flinders Reef off the east coast of Australia. Thank you for joining us today. We'll be joined for bits and time today by our co-PIs who are all working from their homes. So audio may not be continuously narrated, so if you don't hear audio, that is the reason. We'll try to pop in and answer some questions as best we can on the ship, but the entire science team is shoreside. So we have no biological or geological experts on board. While many of us have seen many of the creatures that you see in the video, we at times are taking just as much of a guess as you. So if you do have a degree in marine biology or ichthyology or marine geochemistry or marine geology, feel free to type in your comments and suggestions and share with the audience. This looks like a pretty big squid. Jimbo, our lead tech, is joined us in the control room as well, and he's handling taking frame grabs and stills with our event logging system. And cheerleading, and video directing. These giant eye squids are really cool. Nope, looks like big eyes on both sides. Jimbo asked if this was one of those squids with one eye smaller than the other on one side, but looks like he's got two big eyes. Hi Amy, thanks for joining. We love the squid too. Thanks everybody for joining us around the world. I've seen people come in from Guam in the US and other locations, Toronto, Australia. Aloha Tim. Sherry, you asking what is Sebastian's mission today? We are diving on a set of, we have been mapping a set of reefs off the east coast of Australia on the Queensland Plateau. We have, our science team ashore has identified an area that they are interested in on the South Flinders Reef. In a little while I'll put a subset image in, but while we have this gorgeous giant squid on the screen, I'll leave it up. But we are diving on the west side of South Flinders Reef off the east coast of Australia on Queensland Plateau. So we are gaining some multibeam.
South side of North Flinders Reef?
No, we're on the South Flinders Reef. Yes, we are. So we are on the west side of South Flinders Reef.
Hello, Deb. This is Rob calling from Cairns. Do you hear me? Over.
Yeah, I can hear you great, Rob. Thanks for joining us.
Yeah, thanks very much. It's good to jump in here. For everyone ashore, my name's Robin Beeman. I'm at James Cook University. I'm chief scientist of this voyage. We're all under state home orders because of the COVID crisis. I'm in Cairns, about 300 kilometres away from the vessel. We've been testing all kinds of audio options over the last week. It's still an ongoing exercise. It's not so easy having the broadcast from the ocean floor up to the vessel to myself in Cairns or to the other PIs scattered around Australia and then back and next on board and then stream to you. But anyway, here we are, and we're right at the base of a very, very big wall. We estimate it's probably nearly 100 metres high. And what we think this is the scarp face of a very large undersea landslide. And so this ROV transect was specifically chosen so that it would run along this sharp face. Geologically, very interesting because a scarp face basically exposes all of the underlying rock which makes up these coral atolls. We saw this at Holmes Reef quite distinctly with lots of different layers of rock, one layered on each other like a series of pancakes. It's also a very nice place for biology to attach to. Because as you can see, there's a fair bit of sediment still around. It's this white calcareous carbonate sediment. It's just raining down from above the shallow coral reef. So keep your eyes peeled for what's growing on the wall. There's all kinds of interesting animals, and we'll see if we can find some cold water corals as well. That's particularly interested in those.
So for our viewers at home asking some questions about temperature, currently it's 26 degrees air temp and just slightly 26.8 for water temp. So air and water right now on the surface are very close to the same. But the temperature here at 954 meters is currently 4.5 degrees Celsius. And Sherry asked how many people are on Falkor. Currently we have 25 people on board.
So this is Rob calling in from Cairns. One of our principal investigators is Dr. Merrick Eakins. He's a carnivorous sponge specialist from Queensland Museum. He'll be particularly interested in watching, maybe joining us later, talk about the deep water sponges. He heads up the invertebrate section at the Queensland Museum based in Brisbane, and he joined us a few days ago at Holmes Reef, where he's able to identify some of these smaller sponges. It could be what we're looking at here, but he'll be able to identify those quite well, I think.
And for those of you at home who are asking sort of the plan, I've opened up the Fledermaus screen, so you can see the little yellow square is Sebastian as we're just looking at this wall face. So we'll climb up towards the top of this and then move along it horizontally and then work our way up the side of this reef. So this is South Flinders, the west side of South Flinders Reef. Looks like a nice squat lobster.
Yeah, thanks for zooming in. These are definitely hexactinellid sponges, siliceous sponges. I think we even have a name for those. Silicalex wilsoni is a glass sponge. So in these deeper waters, cool waters, as Deb said, it's about 4.5 degrees Celsius. This is typically where we find these siliceous sponges. As we go up towards the warmer sunlit waters where it's warm and tropical, it's a thriving coral reef higher up in that zone. These sponges tend to be more demosponge-like with protein. You don't find so many siliceous sponges up there. So this is quite a distinctive siliceous sponge found in the Coral Sea, and we've seen them on all the dives we've done so far.
Good morning, everybody. For those of you just tuning in, we are diving on the west side of South Flinders Reef. We are off the east coast of Australia on the Queensland Plateau. I know there were some questions about what we're up to today. We are here to just see what we can, find out what's going on, and look at some interesting creatures in geology. So thanks for joining us. This is Schmidt Ocean Institute, Research Vessel Falkor, and ROV SuBastian.
Yeah, thanks, Debs, and I can add some more context there. So the Coral Sea Marine Park is Australia's largest marine reserve. It's nearly 1 million square kilometres. It sits on the northeast side of Australia. The Great Barrier Reef lies directly adjacent to it, so it runs all along the western side of this particular Coral Sea Marine Park. So it shares common waters, the Coral Sea. Coral Sea is bounded by Australia, Papua New Guinea, Solomon Islands, and New Caledonia, and it sort of finishes. It's tropical. It's sort of lower. The lower part of the Coral Sea is around about where Brisbane is. That sort of transition from tropical to temperate water. So it's a large mass of water, and sitting in the middle of this Coral Sea Marine Park is the Queensland Plateau. It's the world's largest marginal plateau. When I say marginal, close to a continental margin, that being Australia. And so in size, it's around about 280,000 square kilometres in size. So for Australians listening, it's bigger than Victoria, and it's about 4 times larger than Tasmania in area. But sitting on top of that plateau, which is a big carbonate plateau, which is a long geological history, are 30 large coral reefs. These are true coral reefs with thriving, shallow water, tropical corals growing at the surface. And these form the rims of these atolls that we're actually mapping around the edges. Now, most of these 30-odd reefs have a pedestal height of around about 1,000 metres. So the plateau itself is this big, broad plateau. It's relatively flat. It's about 1,000 metres deep on average. And then rising up 1,000 metres right up to the top of the sea surface are these quite large coral atolls. So we're on one of them. It's the South Flinders Reef. The one to the north is North Flinders Reef, and it's much, much bigger. It's quite a big coral atoll, and Debs, maybe you can bring up a Google Earth overlay sometime later and sort of show perspective. But there's a cluster of reefs that we've been mapping for the last 2 or 3 days. There's Dart Reef, named after HMS Dart from 1982. There's another reef called Herald Surprise. It's named after HMS Herald, 1822. These are very old but distinguished surveying vessels that we use, old wooden sailing ships that we used to survey these waters back in the 1800s. And we are now going up the side of one of these. So I'll talk a little while later just about the sort of older, the geological history of these. And of course, as we go higher up the walls here, the rocks obviously are going to get younger and younger. So I'll talk about that in a little while. But just to talk about the expedition in general, these 30 coral reefs have actually been quite well mapped through previous airborne LiDAR bathymetry done by the Royal Australian Navy, of which I was involved with some years back. And we have a general understanding of the overall depths of the water. And I say general because it was only ever done with single beam echo sounders, or if you go back to the 1800s, probably just lead line. So our understanding of the depth is about correct. It's about 1,000 metres deep, but we know nothing about the detail on these deeper waters. So airborne LiDAR bathymetry can really only mapped down to about 50, 60 metres, 70 metres if it's really, really clear water. Below that, we really have no understanding of what the detail was like. And so this expedition was, I guess the genesis of it was, it came out of the COVID crisis when some of the expeditions that were planned in northern Australia by the Falkor had to be cancelled, and so the vessel mobilised over to northeast Australia earlier than expected. And so with a little bit of extra time, we were able to put together this expedition to the Queensland Plateau to really do some justice to understand the detail around the flanks of these reefs that are around about 1,000 metres in height, you know, the full pedestal height. And what we've seen is really quite remarkable. The 3D pictures that the Falkor have been generating are showing huge numbers of submarine canyons, undersea landslides, of which we're going up one now, big blocks that have fallen off the edge. Literally, the whole sides of these coral reefs have collapsed in a long geological past, and they've left great huge blocks, you know, several kilometres across, just stranded down on top of the plateau surface. So long meandering channels that seem to snake across the plateau a long way from coral reefs. We can't really explain those. So there's this remarkable detail that's coming out of the 3D multibeam mapping that the Falkor is doing. But then we have the I guess the joy of seeing the living marine life and the actual rock that makes up these 3D maps in front of us. So that's been really great. And the aim is over these remaining weeks of the expedition is to do 2 or 3 ROV dives during the week, and trying to do this visual sampling of what has been mapped with the multibeam system. So we're seeing some really unusual looking sort of these vertical fissures in the wall. Now, we have seen them in other reefs. They're basically from sediment that's eroding into the rock. Now, this rock, we believe, is just hard limestone rock. So these reefs have a long geological history, stretching back at least 20 million years. And then the whole plateau itself has undergone 3 distinct subsidence phases. And every time that plateau itself goes a little deeper because of the subsidence, the coral reefs either can grow and keep close to sea level where they need the light, or they drown. And we've seen evidence of drowned reefs already. They're basically reefs that were not able to overcome the subsidence rate and match it with the growth of coral. Eventually they get too deep, the coral cannot grow, and it becomes a drowned reef. A give-up reef is another terminology. It's given up. It's not been able to maintain growth. But these 30 large atolls that we're surveying around have clearly been able to do this. They are 1,000 metres high, but the growth part of it is only happening within in that photic zone near the sea surface. So what we're doing now is we're basically flying up the deeper base of these, but we expect that this rock was originally shallow water coral. Hence, it can erode, just like any limestone. It can erode through water and sediment. And what I believe these sort of vertical channels that are eroded in the walls, just where sediment has actually cut down into the rock itself. And we, like I say, we have seen this in other places too. Yeah, thanks, guys. If you can zoom in, it's a little hard to say if it's an urchin or it's possibly just it is definitely an urchin. It's just got very long spines. Yeah, we have seen this in previous dives up near Osprey Reef. We had two of them just like this together, really very, very long spines sticking out from the main test. So being in tropical waters, not only is there a lot of shallow coral reef growing there, but even in the pelagic waters above, there's, oh, that's really spectacular, almost like a big cave. I was going to say this white sediment is just calcareous sediment. It's either sediment that's drifted down from above from the shallow coral reef that's closer towards the atoll surface itself, or it's just drifted down as plankton from above. So what we're seeing here is a very nice big, a big scarp face. The original rock has collapsed. It's probably fallen down onto the plateau surface and deeper below us. But what we can see here is really distinct strata, distinct layering. This is what we saw at Holmes Reef, and it's quite exciting. It does show this kind of wedding cake layer effect that you get with coral reef growth. But this is a really good example. As reef grows, eventually it dies for whatever reason, and then a new layer will grow on top, and then you just get this stacked layering. Originally, this would have all been close to the sea surface, but during these big subsidence pulses, the most recent of which was about 3 million years ago, the plateau just continued to get deeper and deeper, and so all we're left with now are these 30 large coral reefs that we're now mapping around. And so the aim of the expedition is very exploratory, to do the mapping, to try and find out what the detail of the seafloor looks like, given that we had very little understanding. But the ROV dives themselves they're all planned to be long vertical transects. We're trying to understand, I guess, the changes in the biology as you go further up the water column from those cooler water depths right up into the shallow, warmer, sunlit surfaces. So it's very instructive to be able to do long vertical transects. We're not doing any sampling on this expedition. We don't have permits. So the aim of the ROV transects are all vertically upward and sort of continue right through the day. So there isn't a lot of time for stopping. And there's another hexactinellid sponge coming into view. You're looking straight down the ostia, the top of them.
Hey Rob, I'm just going to let you know on Facebook we have the Coral Sea Foundation watching on Magnetic Island. So hi guys, thanks for joining us today. I had to actually Google where you were, and you're not too far away, but closer to mainland Australia. But thank you for joining us.
Yes, thanks to the Coral Sea Foundation. They do a great job of going out and surveying these waters. The shallow water is actually quite well surveyed. There's been a number of expeditions out there, just even recently, up until the COVID crisis really kicked in. But I guess this is the point that we do know. While we know a fair bit about the shallow tropical, the shallow coral waters and the marine life that lives there, on these 30 large atolls. It's below those depths that we have only a very rudimentary knowledge. So most of the work that's been done has been up at Osprey Reef. There's been some deep ROV dives there, the most recent being in 2009 with the German Deep Down Under expedition. And they got a ROV down to around about 700, 800 metres depth. That was the only deep ROV expedition into the Coral Sea that we're aware of until the Falkor came along. And our first dive, we doubled that, went down to 1,600 metres straight up. So it's great. And now this is our fourth dive, and it's just revealing so much more than we ever knew. The data is, the 3D mapping data, of course, will be used time and time again. It gets preserved and archived at Geoscience Australia, which is the main geological organisation in Australia. All that Multibeam data then becomes publicly available through the Oz Seabed Marine Data Portal. The vision data is also captured, not only the video itself, but we capture 5-second screenshots automatically all the way through the dive. And then we put that into some clever software, artificial intelligence software that allows us to do habitat mapping with it. So we're able to relate the marine life that we see with the rock, the substrate that we're drifting over. Like I said, we aren't actually doing sampling on this particular expedition, but we do have another Falkor expedition planned in a few months that will focus here on the Coral Sea and also on the deep Great Barrier Reef. We'll have a very large contingent of biologists on board, and we will be able to do physical sampling of marine life during that expedition. So we might just talk about some of the bigger landslides that we've seen so far. Mentioned that the mapping detail that Falkor has collected is quite remarkable. Right now we're flying up the scarp face. So if you talk about any landslide, The cliff that's left behind after the massive material has collapsed is typically called a scarp. And why it's attractive to us as geologists is you can see the rock strata, and this is what we're seeing in front of us. The sediment that's layering up on it just makes it highlight that little bit more. But clearly, during this expedition, we've seen quite a lot of quite a lot of material falling off. This is interesting. Hard to say what this is. Have to remember we were on the slope of a large atoll, and so there is shallow water marine life that can drift down from above, and we've seen that in previous dives. We've actually seen shallow water gastropods and in fairly deep water here. So it's not to say that what we just saw then could have actually just fallen down from above. But just going back to the landslides, clearly we're flying up this very big wall. It's over 100 metres high. This is a scarp. Now, the original boulders, the bits, the debris that's collapsed, are now either scattered around us or on the deeper plateau floor at its base. And we've seen plenty of evidence where these rock boulders are now stranded out about 1,000 metres depth, some of them really huge in size. And on the Great Barrier Reef margin, which is just opposite us here, in fact, the Great Barrier Reef in distance is about 90 kilometres due west of where we're currently doing the ROV. We found also lots of evidence of landslides, either sheet landslides, sort of thin, narrow layers, but over a large area, sort of stretching out 20, 30 kilometres from the original scarp face, or really large masses of boulders that have collapsed. So it seems to be an area that does get a fair bit of erosion, and we're now flying up the scarp face of it.
Thanks, Rob. I think we have Tom. Tom, are you there?
Yep, I'm here. Can you hear me?
Hi, Tom. Yeah, we can hear you. Great. Thanks for joining.
No
Hey,
problem.
Tom.
Hi, Rob. I said I do have a 4-year-old who's super interested when the squid and stuff are around. He may join in. He's very interested in the octonauts and things like that. So our lounge room's turned into a submarine. It's the first time he's joined me on any of these field trips. But we'll see. We've got to find some more interesting life for him to join in again.
Great. So just so you both know, you're live on YouTube and Facebook. Say hi to our audience. Thank you.
Hi, everyone. It's good to have a little bit of time to join in. And that looks like an octocoral of some sort of Gorgonian.
Yeah, Tom, and just above it is that's almost plastic bag-like feature. That's really the baskets left behind from like basket eel nest. It's a little bit like the parrotfish on the shallow coral reefs. They put this mucus bag around them supposedly for protection, but we've seen eels actually create this, and they leave this basket behind, and it just stays there until water washes it away.
Looking closely, it could be a zoanthids or something as well. Pretty interesting anyway. If we had an arm, that's probably something I'd be interested in collecting.
You can see that that basket we assume it's just mucus. It's even got some, looks like some brittle stars sitting in amongst it too. That's quite amazing. So that long, clear, plastic bag-looking feature that's made by an eel, and we have actually seen them previously actually sitting inside that basket, where presumably it's a nest or it's some sort of protection. Who knows? But we've seen these at this depth before. So one of the views, there was a precious coral, corallium. That's quite possible. Yeah. In fact, I was involved in a paper we wrote at Osprey Reef on that German Deep Down Under expedition, where we identified the first record of corallium in coral sea waters. So corallium is a precious. Well, it's called precious coral, and it's even used as jewellery around the world. So when it dies, it has this very, very dense pink bone that retains that colour, and you may see it in markets and jewellery stores. Fortunately, it's over-harvested in places like the Mediterranean, but here in the Coral Sea Marine Park, much of the area is no-take zone. There is very little commercial fishing, mainly tuna fishing, some long line type fishing, but there's certainly no diving for this kind of corals. So this is Coral Sea Marine Park is one of the world's largest marine parks, and it's certainly the largest here in Australia. But it's a very pristine environment, and we're now getting a really unique look into the deeper parts of that Coral Sea Marine Park with the RV Falkor. So Deb's just curious, where are we in regards to the plan of the transit? Have we come up over? We're at the top of that big scarp wall now. That's how it appears to me.
Yep, Russ said we just got to the top, so he's going to zoom out and give you guys a little bit of a picture here, and then sort of work down a little bit, and then I guess we'll start working north. So seems to be the top here. It seems to be tapering off a bit. So yeah, we're just at the top of that sort of first 100-meter incline wall that we went up. So we'll come down the wall a little bit and then work our way north. For those of you at home, I'm just putting the inset map in, and what we're talking about is this color change from dark blue to light blue, where just the yellow box is this vehicle, obviously not to scale, so you can actually see it, but we're just reaching the top of this first wall step, and then we're going to start moving our way along that feature, and then working our way up the side of the reef.
So how shallow are we looking at, hoping to get today?
As shallow as we can go. So pretty much, yeah, we're gonna try to go up as far up as we can. We were able to map this morning and see about 70 meters up on that wall, basically where it starts to go into flat reef area. So So that's our plan, is to try to endeavor to climb all the way up, and potentially on this last sort of wall face, hope that we can see some shallow stuff. The top part of the end of this dive has a little bit of an area where it's the sediment slumped down, and so we're hoping to get up along that that boundary.
Well, thanks for that. Obviously, with a strong interest in the Mesophotic, it's very interesting to get down to that area. Now, there's obviously been a little bit of work done in the Coral Sea, especially Flinders and Osprey and Holmes Reef on the Mesophotic, but really in terms of a little bit of deeper ROV work with much smaller ROVs and not as high quality vision. But even the diving, it's really only down to about 40 metres. So that real Mesophotic, lower Mesophotic, so 60 to 150 metres or so. It's really interesting, but we know very little about it. So yeah, it's really good to see this out there. I wrote a chapter in a book on Mesophotic coral reef ecosystems of the world, which was published last year, and Rob and I were both authors on that chapter, and we did report what we knew about the Coral Sea, but it wasn't very much. So it's great to have these sorts of definitions where we can, learn so much more.
Yeah, thanks, Tom. Yeah, so for background, both Tom and I have been working out in the Coral Sea for over a decade now, and we've been out in larger ships and smaller vessels, and probably the most memorable one was a small boat Tom and I went out on 2010. It was a boat called the Coral Emperor, and we had a small ROV. I think it was the little Seabotics ROV. I think it goes to 150 metres depth. We did a lot of scuba diving, a lot of photography, but we were able to take the ROV down to around about that 150 metres, and from there we're able to make records of deepest known species in that area. So it was quite interesting. Tom, I'm sure you'd be able to know a bit more about this than I, but photo zooxanthellate corals that require sunlight to power the zooxanthellae that live within their flesh. They're sort of typically lower depth limits, around about 60 metres. There are depth specialists that can go a bit deeper, but that sort of 60 metre mark, they become more soft corals and azooxanthelic. Do you want to talk about that a little bit more, Tom?
Yeah, sure. Thanks, Rob. Yeah, that's what we're finding. I mean, I guess Rob and I did a trip in 2007 on the Southern Surveyor, which is the Australian government's research ship, on the Great Barrier Reef rather than in the Coral Sea. But we found that we really did see this changeover in the fauna at about 60 to 70 metres, where we really went from sort of an assemblage dominated by phototrophic organisms, whether that was hard corals in places, sometimes soft corals, sometimes even phototrophic sponges were very common. And then once you get below this 60, 70 metres, we really start being dominated, the ecosystems really start being dominated by non-phototrophic taxa. So in this part of the world, it's particularly octocorals, so typically gorgonians and other octocorals. And then, but also things like sponges and things like that. And since then, we've really found that that 60 to 70 metre depth range really seems to be a global phenomenon. There's breaks in the composition of ecosystems all over the world at that 60 to 70 metre depth and in the tropical oceans. And we found that tends to correlate most strongly with light, between about 10 to 1% of surface irradiance, where you really start to get this changeover in the fauna. And while you do get sometimes, there are other factors that affect that. So sometimes, whether it's the clarity of the water, or sometimes We find on these steep seamounts and things that the aspect is important, because sometimes if you're on a steep wall, you're getting less light because you're shaded. If you're even at relatively shallow depths, half the time the sun is shaded by the reef itself. So there are things that make a difference. But even though the fauna is quite different, so in the Caribbean, there's, for example, there's generally less octocorals, but more of these big sort of three-dimensional sponges. Whereas in the Pacific, a lot of the sponges are sort of smaller and more encrusting. So we start to see the dominant benthos in this area being the octocorals. But we have found from the Red Sea, across the Pacific, and even in the Atlantic, that this 60 to 70 metres is a real transition where we start to get this very different biological community to what we see in shallow reefs. And so that's been pretty interesting. There are phototrophic taxa down there, corals and things like that. But again, they tend to be really specialised. There's a few particular taxa of corals, Leptocerus being the main one, but also a few others that really do seem to dominate this habitat. And there's some theories about why that is. They've got special adaptations, obviously. But even things like the architecture of the skeleton, so the actual calcium carbonate skeleton is designed at the microstructural level to scatter light, which makes them much more efficient at photosynthesizing than the corals in the shallow. So they've really got some really clever adaptations that we're only just starting to learn about to enable them to survive in this really low light habitat.
Yeah, thanks very much, Tom. So the other dives we've had so far, we haven't quite made it up into that real mesophotic zone. We've just been at the very lower limits of it. I think we got up to around 200 metres on our last dive, and we're just starting to see some of those octocorals coming into view. The other giveaway was we could actually see this crustose red algae starting to appear on rock, and it's very patchy, but it does need light to be able to photosynthesize. And we were starting to see that around about that 200 meter mark before we were able to had to bail out with with SuBastian ROV. We may get a chance today. Certainly the weather has been improving over the last day or two. It's been very blustery out here in North Queensland. And I'm just curious, what's the weather like where you are, Debs? Because you're about 300 kilometres away from.
So I haven't been outside yet today, but the reports from the ROV team who deployed the vehicle said it was very pleasant outside today. So I think we have pretty good weather. Light winds. We were planning originally on diving tomorrow, but the weather's supposed to pick back up again, so we moved the dive to today because we thought that the weather would be more conducive to getting closer to the reef and allowing us to have a better ride while sitting here with the vehicle in the water. So yeah, it's quite pleasant out today.
Yeah, thanks, Debs, and happy Mother's Day for any mothers looking. My wife got her a cup of tea and breakfast in bed and presents. It was a nice way to start the day. Now, just looking at the rocks here, we're definitely seeing some interesting rock strata. It's not just about the layering of the coral that have created these large mounds, but there's clearly evidence of rubble forming. So we pass big sort of layers of conglomerates, boulder conglomerates. So you can imagine that cyclone events or things like that are constantly pushing rocks off, and clearly in a long distant geological past, these layers of boulders have coalesced together and now forming the original rock. So it was quite distinct as we went back there. There's something rolling down the slope. Because gravity gravity affects everything, and even on these steep slopes, the sediment is constantly raining down from above. Those rock boulders, obviously, in a long geological past, but everything falls down below, and we've got this whole suite of deposit feeders and scavengers who are waiting for this material, this soft carbonate sediment coming down from above.
So Rob, real quick, I'm going to jump in. I just showed the viewers at home the picture from our aft deck, so you can see the different picture. For those of you who watched the dive the other day, there's a lot less wind today. The seas look pretty calm, and it's blue skies with clouds. So it's a pretty nice picture out there today. As we move closer to the reef, I'll show this camera again, and hopefully you can actually see the surface of the reef.
It's interesting, while light seems to be one of the main sort of dominant, the primary reason in most cases why we see this transition from shallow to the mesophotic, where there's another transition where we really go from the bottom of the mesophotic into the deep sea, I guess, for want of a better word. There's been a few terms to describe it. The mesophotic tends to, it's been classified as being middle light. So still, while it's not as bright as the surface, obviously, there's still enough light for photosynthesis to occur. Below that, there's even a zone called the dysphotic, which there is some light, but not enough to sustain photosynthesis. But this is where you'll often see things like fish, but also cephalopods and things like that with very large eyes, and lots of time can create their own light, like through bioluminescence and things, and they can use this to disguise the shape and things like that. And that's because, especially with these well-adapted eyes, there is some light. So the animals that live there can use that and utilise that to their advantage, even though there's no photosynthesis. It still plays an important role in the ecosystem. But there's also influences of temperature. So obviously, as we go up from the deep sea, I'm not sure what it was at 1,000 metres this morning, but I'd assume somewhere around maybe 5 degrees or something like that. And then obviously once you get up towards the surface, we start getting up towards, at the moment it's probably somewhere around 26, 27 degrees. So quite a steep temperature gradient. And in that sort of 200 to 400 metre zone in the Coral Sea, you start to see a thermocline, which is a real transition between the cold deep sea water and more of the shallow surface waters, called the mixed layer. And that depth can fluctuate for various reasons and at different timescales. So things like even El Nino southern oscillation in the Western Pacific will make the thermocline rise up and down. So that sort of transition zone between sort of 200 to 400 metres can be a difficult place to live, because sometimes it'll be quite warm and be really subjected mainly to surface waters, whereas other times it's much more similar to deep sea conditions. So if you imagine, most animals that live in the deep sea are used to a fairly consistent environment. It doesn't change much at all with the seasons or anything like that. So these creatures, this zone is a really interesting zone. It often doesn't have a lot in it, but it's in terms of the benthos, the things that can't move. There's a lot of migrations of things that live in the water column through that zone, even from day to night. But it's interesting to try and understand a little bit more about this transition from this sort of what we call shallow, I guess, which includes the mesophotic and down to about 200 to 300 metres, and this real transition into the deep sea.
Yeah, that's right, Tom. And that's why these long vertical transects are so important, so we can get an understanding of the benthic assemblages versus the depth. And it's great to be able to get them from all below, rather than, previously we'd be starting from the surface and sort of trying to push down deep, but we never quite break through that mesophotic zone. But here we're getting that lovely transition through And you're right, that sort of zone around that, say perhaps 400, 450 metre mark, is a really definite thermocline. So we have been actually monitoring quite closely in the previous dives where the temperature is. So we started today at about 4.5 degrees Celsius, which is 1,000 metres down. But when you're getting up to that 400 metre mark, you're transitioning quite quickly from sort of like 9 or 10 degrees, bursting straight into the teens, 11, 12 degrees Celsius. It changes quite dramatically. So that upper surface layer is warmer, sunlit. It's well mixed from wave action. Below that 400 metre mark, it's what's called subtropical mode water. And even deeper still, say below around 900 metres, you're getting into subantarctic mode water. It starts getting much, much colder. But right now we're in the subtropical mode water, and it'll just slowly, gradually rise up as we go up in the water column. But for the most part, we are dealing with cold water community. But when we hit that sort of 400 metre mark, you're right, we don't see huge amounts of benthos there. We do see the occasional scavenger like echinoderms, echiurine worms and the like. But it's not until we probably get to around that 350 metre mark do we start seeing the first of those soft corals appearing, which is that dysphotic zone that you're talking about. And the last dive we saw these beautiful coloured stylasterid corals and purple soft corals. So they sort of start appearing around that 350 metre mark.
A few questions popping up just saying, we can't collect, and obviously, the point of this is really just to do some exploratory stuff. It can be a bit difficult to do that in terms of when you see really interesting things, not having the capacity to do it. But we're hoping that in the next, there is another trip coming up where we will be able to do some collecting. So it'll be really good that we have some good detailed maps and some idea of what's here. And just speaking to Rob before, we've done one of these trips on one previous trip into the Coral Sea, one of these big transects from the deep sea into the shallow. So it'll be really nice to have them from multiple places to really understand a little bit more about how consistent this is among the different locations.
We're getting quite a lot of sediment pulled up into the water column. This is just from the ROV thrusters, obviously, but I guess it does show the fine drape of mud, carbonate mud. This is this white snow-like material. It's either drifted down from above in the water column, so there's plenty of calcareous plankton that drift around, live in those photic zone, and when they die, they fall down. It's even called marine snow, but if you would pick it up, most of it would just be little pieces, tiny little the remains of plankton. Alternatively, it's a coral, rubble, and algae and foraminifera that have basically drifted or slid down the slope that have been growing up on the shallow coral reef that lies above us. So clearly, I often say these things are big carbonate factories. They're just constantly growing and eroding, and that material, if it's not incorporated into the coral skeleton, has to go somewhere. And generally, it's falling and draping down over all these lower flanks, and that's what we see. And so it does have an effect on the benthos. This is what we've noticed in other places. Some work Tom and I did, where you get too much sediment building up, typically low gradient slopes, it tends to suppress where sessile or non-mobile animals live. So corals do need something to attach to. Where there's just too much sediment, they cannot attach to the rock underneath, and hence you often find rocks almost like little oases in a desert of sand. This is where you find lots of marine life. It looks like we're going through a big boulder zone now. So these would have been rocks that have been knocked off higher up, and they've just tumbled down the slope. It's quite a dramatic landscape, I think you'd agree. And on that, there has been, a numerous cyclones through this area. So this is definitely a cyclone zone. Just in this area here, Cyclone Yasi went through. I think it was around 2011. Very big cyclone. I think it was a Cat 4. Swept through here, made huge damage on land. But you can imagine what it did to the coral reefs here. Looks like a nice sea cucumber on the. Now we've had some help from taxonomists at Museum of Victoria, who are holothurian sea cucumber specialists. Typically we're seeing these large purple sea cucumbers and perhaps two different kinds, maybe 2-3 different kinds of smaller pink sea cucumber. And we've got some possible identification. It's an Elacipodida, Benthodites species. We don't have the actual species name, but the genus is very likely Benthodites, and it has this beautiful swimming motion when it's disturbed. You see that large disc, that's its mouth. On the lower side, that's the anus. You can almost see its gut. It's almost translucent through the middle. So, and it's got these little protuberances on the upper surface. And thanks to our ROV pilots, Ben, Russell, and Chris, following that, it's just beautiful to watch in motion. Gents, would you mind putting the laser beams on? We just get a sense of scale. Okay, for the viewers, have a look at the bottom of the screen. You'll see these two little white dots. They're exactly 10 centimeters apart. So my guess is we're looking at about say 15 centimeter wide, maybe even 20 centimeter wide sea star on the side of this rock. Those laser beams point directly ahead. They don't, there's very little diffusion, so they give us a very good understanding of scale in the deep ocean, and they're typically mounted, they're often mounted on ROVs. You can see these hexactinellid glass sponges, little cup-shaped sponges. These are Silicalax wilsoni. We had previously identified them in 2009, a German deep down under expedition. There were some sponge specialists there too, and we were able to get an ID on these sponges.
I'm going to have to head off, guys. Sorry, but hopefully I'll be able to get back on a little later on, and I'll catch up as much as I can. So it's been great joining you.
Yeah, thanks, Tom. Hopefully you can join us a little later in the day when we get closer into that Mesophotic zone. You might be able to put some names to faces up there, but really appreciate your input there. Thanks.
No problem. Thanks, Rob. Hopefully, yeah, we'll be back on later today.
I mentioned earlier about the cyclones that come through here. We could be looking at the remains of cyclone debris as well. Some of these boulders are quite huge, so very precarious the way they're sitting there. But I mentioned Cyclone Yasi 2011, a very large cyclone, hurricane to our northern hemisphere listeners. This area had been swept by a cyclone. In fact, the expedition that Tom Bridge, who was just on here, and I did in late 2010 or 2011 came through, and we had a look at this Mesophotic and shallow coral zone at Holmes Reef, which was the reef that we studied just prior to coming to this area. And it had really been swept clear of corals. Most of the coral life was down at about sort of 20 metres and lower, because that whole upper shallower coral surface had been swept clear by the cyclone. But we have been in places where the big boulders, big chunks, literally cut out of the shallow coral reef by the huge waves generated by these cyclones. So it's not surprising we can see big boulders down here on the steeper flanks and the deeper waters.
Morning, Rob. Can you hear me?
Yes, Jody, loud and clear. Do you want to introduce yourself?
Good morning. Yeah, so my name's Jody Webster. I'm from the University of Sydney. I'm a marine geologist. I work on margin systems and coral reef systems. And yeah, I've just been watching some of the this morning and enjoying some of the amazing outcrops that we've been seeing. Rob, do you have a map of catch me up on where we are in the ROV dive in terms of, I guess we're working our way up the submarine landslide?
Yeah, Deb may be able to help there, but we have actually already risen above that very, very, very large scarp face. It's probably about 100 metres high. That was at the very base, at the very start of the transect. And we're kind of just running along the top of the wall because we're slowly rising, of course, getting closer and closer to the shallow coral reef itself. But, you know, we're probably looking at the top part of that.
Right, the top part of the slide scarp.
Yeah, Jody, I'm just going to try to bring up, I shared my screen. Right. Sorry, I shared my screen, and I'm just going to put an overlay of Fledermaus in here real quick to give you guys an idea of where we are. Hopefully you can see that. I'm also not sure if you're watching on YouTube or Facebook, but so I was just discussing with Chris,
who's both actually. Yeah.
Okay, I was just discussing with Chris, who's flying right now, because he actually had to kind of pull away as we were seeing larger boulders. It looked less and less like a ridge, but we're also so the vehicle is flying with its sort of nose or front facing the ridge, and then working along it towards the top. And as we start working to the north, then to the left side of the vehicle, it'll start climbing up both hills. So it's been changing topography. This looks to be a lot more like layering, like we saw the other day that we're seeing now. So we are about here in our track. And let me just confirm that. Yeah. So we're kind of right here, and I think there was maybe a little bit more sediment that came down. So we're just getting to be where that apex of where the whole slump feature is at the bottom of the reef.
Right, yeah, some of the imagery, yeah, you can now see some what appears to be near horizontal layering there. So we're cutting through some sort of stratigraphy there, which is presumably the some of the previous slope deposits that have accumulated on the flanks of these platforms. Yeah, there seems to be definitely more sediment here than we saw on the Holmes Reef slides.
Yeah, definitely. And Chris is just saying he's going to fly down a little bit so we can kind of see what's a little bit lower.
You know, I downloaded the grids that you put on there last night, so I'm just going to try and extract those and have a look at that and try and zoom around.
Great, yeah, just
the data as we're flying over it.
It's pretty preliminary, and it doesn't have the last bit that we mapped this morning. We got really close up to I think our data actually meets up and touches where the LiDAR and was at the same place. So yeah, so it's not edited. It's very preliminary, but you should have the general area of this area. The grid I'm showing on Fledermaus right now is a 10-meter grid, as opposed to I think what I uploaded was a 30-meter grid.
Some sort of starfish attached to the wall. What is that?
Yeah, it looks like a starfish. Chris says he thinks they're cute, so he's going to stop and look at them whenever he sees them. And since he's flying the vehicle,
yeah.
he gets to make that decision.
Yeah, of course. I should preface, I'm by no means an expert in soft, squishy things. So hopefully Merrick is online and can jump on.
Yeah, he just joined us on
biologic knowledge.
He just joined us on our Zoom call. So Merrick, do you want to say hi real quick?
Hello, good morning. Yeah.
Good morning, Merrick.
Morning,
Good
Merrick.
morning.
Do you want to introduce yourself?
Yeah, I'm Merrick Eakins, Collection Manager of Sessile Marine Invertebrates at the Queensland Museum. So usually things like sponges and corals and things like that. Yeah. I can see lots of glass sponges there, and and a couple of starfish. Yeah.
So for you guys at home, just so you know, on the Zoom call, I'm sorry for our PIs that are joined on the Zoom call and you're hearing their audio through Zoom actually. I've just turned off the screen share because it tends to, I think, be a bit delayed. So what you're seeing is the 4K science camera, so you won't see any overlays if I share them. So if there is something you want me to demonstrate or show to the audience at home, just let me know and I can do an overlay, but you won't see that overlay unless you're watching on YouTube and Facebook. And just so you know, there is about 20 to 30 second delay on what you see on YouTube and Facebook from what we see here in the ship.
Dad, is it possible to pop up another overlay to show where we are in the bathymetry again? I'm just looking at the bathymetry now on my screen. I'm just trying to understand exactly where we are in terms of this scar.
Sure, hold on one second. Did the screen share work for you, Jody?
Did you?
Yep. Did the screen share in Zoom work for you? Was that were you able to see it in that?
Yeah, I saw it very quickly. It was quite small, so maybe it would be possible to see that again.
Okay, so I'm sharing that screen with you. If you make that screen share bigger on your computer, I'll share that with everybody at home as well. Okay, so you should see the inset show up now. And I'll put the overall larger grid on.
Right.
Standby one. So we are, if I zoom way out, this is South Flinders Reef.
Yeah.
And we are on the south side of this slump area.
Ah, okay. All right. So, yeah, because we were discussing yesterday about being a little bit further to the west on the larger expanse. So the decision was we'd be a little bit further east to this dive. Okay, now I can see where we are.
Yeah.
Yeah. So we're on essentially the eastern side of this quite spectacular failure, which is in the order of 5 kilometers across. So that's quite amazing.
Yeah, so I believe, if I just verify, this is right now looking north up. So the sort of northern side of that slump, and then we're on the southern side here.
Right.
And we are just starting to work into where the two sort of meet. So we'll probably start seeing a little more sediment, and then as we start working up the side of the wall, I'm going to put the 10-meter grid back on because you can see the detail a little bit better. We're going to be coming up to this next step, and then working up what will probably be a bit of a sediment slope, working our way north again, and then hopefully up this wall face right before we get to the top.
Well, I can see the bathymetry finishes at about 220. Is that correct? That's the target of where we're trying to get to in this dive.
Well,
or shallower.
Yeah, shallower. We're going to try to get up as high as we can before we need to come out. So So I think at some point here on some of these more sandy bits with less interesting things, we'll probably scoot along quicker and try to make up some time so we have some more time to look at the steps. But this interesting step here.
Oh, that's interesting.
Yeah.
There's some really, this horizontal, these lineations. Is it possible to have a closer look at that with the wonderful cameras that we have?
Yeah.
I was wondering that's just some sort of...
I think there's a real step here, so it'll be interesting to see once we get there. So we'll hopefully be able to move, see it along the edge there. So I think Rob jumped off for just a little bit, but you and Merrick can feel free to jump in and narrate.
Sure.
And if you need me to show anything, just give me a holler. Thanks, guys. I appreciate you joining.
Sure, no problem. Incredible scar.
Yeah, there's a small fish there in the picture.
So Jody, this is obviously scarring from the slide. How long ago do you reckon the slide would have happened?
That is a good question. I suspect this is quite an old one because it goes right up to the it seems to be the shallow parts of the slope. So, and then we've had subsequent reef around this. So I suspect, this is quite old. And we've done quite a bit of work in the Great Barrier Reef trying to identify and date these slides. And it's quite a tricky business actually to try and figure out how old they are. The way we've sort of looked at that is taking deeper sediment cores more distally, and where we can see the transition between the undisturbed sediments at the tops of the cores and the chaotic deposits, if we're lucky enough to actually see that actual surface. And then we can, depending on the age of the deposit, we can then get some idea of the minimum age of when that slide could have occurred. But it is a tricky business. But I suspect this one is quite old, in the order of hundreds of thousands of years. But looking at the bathymetry data, there's this probably large single failure, and then there's smaller failures around that, which would probably happen or would have happened after the event. So they can be, this scarp or this flank has a whole series of different generations of slides that have occurred at different times. And I guess question for you, Merrick, are you surprised or not at the lack of biota attached to these walls? Is this what you would expect? There's some things, but it doesn't seem to be really profuse.
Yeah, this is sort of similar to what we found when we went to the Osprey in 2009. It all depends on the amount of snow that's coming in, really. It's got to have a good area that's in high current for most things, because they're filter feeders. So they've got to be, but not so they get covered in snow. So some of them can attach to soft substrate, but that'll usually be like on the this floor or something. But a lot of it will like that rock that's hanging out. So that's why I really like a proper vertical surface. It's really good, or overhangs. And you see that sometimes you'll run across like a boulder or something, and suddenly you'll see this mass proliferation of life all over it. But if it's just getting constantly rained on by our carbonates, then I mean they've all got processes to move it off. But if you just keep getting buried, then it makes it hard to get the proper nutrients. Like you can see this one here hanging out from the side of the wall when it's got something good.
Is that a deep water coral of some sort? What is that?
I think so. I can't see at the moment. I can't see the conference thing. I've only got a tiny little thumbnail. I can't see
It looks
bigger
like
than that.
it looks like a black coral from here. You can
there.
definitely see the stalk is dark, and there are like very translucent polyps on it with a brittle star attached.
Yeah.
Brittle stars attached. That's the thing's waving. Yeah. Okay.
Yeah, the pink one's waving around. Yeah.
Beautiful.
Leg around looking for something else to hold on to. Yeah. Yeah, thanks for that, Deb. Yeah, I think it's a black coral now. I can see it again.
Sorry, Jeremy, we just moved on. We didn't get quite as much of a zoom. Yeah, we were zoomed in as far as we could where the vehicle was flying off the wall, so that was as close of a zoom as we could get on that coral.
Right.
Jeremy just sent a message on Facebook, which is what I was replying to. These fish are quite interesting.
Yeah, sorry, I know nothing about fish. Can't help you on that one.
Similarly, I'm not much help.
One of the guys from Sorrow, or Glenn, who was on the other day.
Yeah, I wonder.
Museum,
I haven't seen him jump in today, so.
Yeah, as you were saying before, Jody, it could be hit and miss on whether you get the biodiversity or not. And as you probably know with rock dredges, that's why a lot of times you'll come up with obviously rocks that are the anchor sort of snags, but trying to get biodiversity stuff like that is it's quite limited. But sometimes it's amazing what comes up because you snag a rock and there it is attached to the rock. So.
Yeah, that's right. So yeah, we were doing a project. I think I mentioned this last time I was on, but yeah, we were doing a project off Fraser Island, looking at submarine landslides there, and there was a couple of attempts to actually use a rock dredge to dredge some of the scars. The idea was to try and get at the substrate, and then we were lucky enough to break off some harder bits, which had some black corals and bamboo corals attached to them. So the substrate was lithified enough such that they could attach their holdfast, and so they're obviously using that scarp surface as a substrate in the way that we've seen here over the last days in some of these dives.
Looks like a nice holothurian there hiding behind possibly a glass sponge there. Yeah, see the holothurian's got some old feeding arms at the front there. I like holothurians and jellyfish. They've got a totally different approach to dealing with incredible pressures. Instead, they just go, okay, we'll just fill our bodies with water and be at the same pressure as the environment, rather than trying to conduct hold a skeleton or exterior thing to hold that pressure our way. So, that's really cool. Can't quite see. You can almost see the tentacles on that octocoral there. Yeah. collecting the sponge after all. It's good. Fascinating those off the corals. I'd love to see more of them. I noticed earlier the other day I had a whole lot of the gold corals, the chrysogorgias, and then we had a lot of the ones like Norellas and things like that, which were down there. I think we're coming up, so we're probably past the depth now.
What are those white patches?
The guys are just
Yeah,
stopping to get
bits of
zoomed in.
Mm.
Yeah, go over that way, yeah. Towards the left, Ben, yeah. Over there. Yep. There you go. Keep going with your lasers. There you go, Ben. Keep going and center. There, zoom there. Yep.
Is it just more sediment, or is it some sort of mat?
It might be some sort of bacterial mat or something. We're trying to get zoomed in here on it to try to have a closer look. I don't know. Hard to tell. Take some frame grabs, but yeah, it's pretty hard to tell from here. There doesn't seem to be much of a step from one sediment type to the other. Thanks, guys, for looking.
Thank you.
How far apart are the laser beams?
They're 10 centimeters.
Okay, thank you.
Just going to say a quick hello to all of those watching us. This is the Schmidt Ocean Institute research vessel Falkor and ROV SuBastian. We are currently diving on the South Flinders Reef on the west side, and we will be in the water till about 3 or so, maybe slightly later this afternoon. We are currently at a depth of 832 meters. The water temperature is currently 5.3 degrees Celsius. It is a balmy 27 degrees Celsius outside, with nice calm flat seas.
Another holothurian?
Looks vaguely like a holothurian. It's either that or an ascidian, but I think holothurian is probably a safer bet at the moment.
Oh, that's interesting. Yeah, that's an
What's
interesting
that,
deposit
Jody?
there.
What would you like us to stop and zoom in, or?
Yeah, if possible, yeah. So that sort of rough outcrop that sort of steps up. I think it's a
Yep.
nice cross section of some of the deposits that we've cut through and are draping down. From this distance, they look quite coarse, and it might be great to get just a bit of a close up of that, if you wouldn't mind. There may also be some interesting biota attached to the hard.
They're just getting set up and orientated to do a bit of a zoom in.
Mm. Mm.
Jody, Chris wants to say hi to your kids. He's flying the vehicle, but he wants to say hi.
Oh, I can grab one if you want.
Sure.
Okay.
Tell us who you have with you.
Hey, Lil. Lil.
Oh.
The ROV pilot wants to say hello. You want to come say hello? You can. Just come say hello. Okay. Yeah.
Hello.
Hello. Hold on. I'm gonna pass you over to Chris. 1 second.
Hey, Chris.
Yes. Hello, Lil. How are you? Hello?
This is actually Scarlett.
Oh,
this
Scarlett,
is
sorry. Okay, hello, Scarlett. How are you today?
Hi. I'm good.
Yeah? Are you enjoying what you're seeing?
Yeah.
Yeah, right now we're 830 meters under the ocean.
What? I can't swim that down.
We can't either. We have a robot to do it for us.
A robot?
Yes, named SuBastian.
Yeah, so it's under the sea.
Oh.
We get to fly all the way down to the bottom of the ocean and see what's down there.
It looks too dark.
Hold on.
Wow. So yeah, we're seeing some really nice.
Thank you for joining us.
Stratigraphic pattern. You want to say bye-bye?
Bye.
Yeah. Who's your favourite character right now?
We did. Sorry, guys. Our audio, if you can hear me, our audio on the ship just got lost, so we'll be right back with you. Thank you so much, Scarlett, for joining us.
All right. Thank you. Bye-bye.
Can you please tell me that I to go riding?
Hello, I'm back. That was Scarlett.
Could you please tell me that I go riding?
Oh, beautiful. Like stalked crinoid there.
Oh, yes.
Oh, yeah. That's good find.
A feather star?
Okay. Sorry. Now we have you back. Thanks. You guys were always live. It's just we couldn't hear you on the ship. Little technical equipment difficulty trying to pass it across the control room. But thanks, Scarlett, for joining us.
Wow, what a landscape. That is spectacular. Oh, we're about 800 metres?
Yeah, 833. And if you can see, there's an altitude on the side, so we're seeing it about 13 meters below the ROV. So we're kind of flying up above the bottom, but along this wall.
Yeah, I can see that information on the YouTube, but not the Zoom screen, which has the better view. But
yeah,
that's fine.
You don't have the overlay.
Ooh.
Oh, this is one.
It looks like there's a lot of sponges, yeah. That might be worth a look for the...
They'd like you to zoom in on the sponges, guys.
Yeah, they're super fragile, but they'll be definitely a new species, those ones. We have to come back and collect them. These are ones they'll be like fragile, like champagne flutes, so they'll be the challenging ones to pick up. I'm sure you amazing pilots will be good at that.
Yeah, they've gotten quite the techniques
Yeah,
of being able to use the arms and the coral cutter rubber to actually be able to pick up some very gentle, soft things. So
yeah.
Now, I have a question on that to the ROV guys. Yeah, in terms of the difficulties of trying to sample on these vertical faces, and I guess in terms of sampling soft things, but what about breaking harder rocks off? And what's the technique there if you're unable to land the ROV on a stable substrate? Is there ways that they're able to anchor themselves somehow to a vertical face? Are there techniques for that?
Yeah, tell them to fly, push onto the wall.
here, I'm gonna pass you over to one of our ROV pilots to let him describe that.
Yeah, what we do normally is we're gonna anchor ourselves on the wall. We'll just fly into it until we're stable. Then we can break a piece of the rock or collect a sample off the wall. It's pretty stable at that point. Yes.
But you actually grab the wall, is that correct? With
no, we're just pushing into it. Right now,
okay, all right.
Yeah,
So
we're gonna park ourselves, and you can see how stable it is. As a sample, Chris is gonna move into the mountain, into the wall. I'm sorry.
The powerful thruster motors. You have much current out there?
A little bit going from our port to starboard. Yeah. I'm gonna push in right here.
Yeah, as you can see.
So they can see your sit camera now.
Ah.
They're looking at that.
Yeah. Once Chris gets himself settled, it's gonna be pretty solid, and we can do our collection from that point.
Alright, so yeah, what I'll do is I push into here, and when I settle out, it's kind of hard because there's an overhang, but I would settle out and push onto there and stay. It's pretty much pretty stable. Let's do it right here because there's no overhang above me anymore. Alright.
Yeah, that's quite stable. So I guess when we come back next time, we'll have a chance to be able to do that.
Yep. So yeah. So once we do that, and I can push as needed to kind of counterbalance the pressure that we used with the arms, I can fly it harder into something or up or down to kind of keep us where we are to break anything off.
Right. Excellent. Thank you, guys.
How fast can SuBastian go through the water? It has to.
Did you hear that question?
What was it?
How fast through the water can SuBastian move?
It depends on the current.
Assuming no current. Yeah.
Assuming no current.
A couple knots. Yeah.
So can you not hear them anymore now?
Yeah, here.
There's quite a lot of sediment raining down in this particular area.
Yeah, we have current coming from north to south. and we're on a fairly flat face to the left of us, so it's probably just pulling a bunch of stuff down into the water column.
Yeah, we've lost our exposed outcrops, or at least those harder outcrops.
Yeah, it's like
Yeah, it looks like a lot more vertical face here.
Yeah.
Give them HD2 to give them a reference.
HD2. Let's see if I can put that up.
Alright, yeah, we're in a gully. We'll have to come up. We'll definitely have to come up. Pull me in. Pull me in, pull me in, pull me in.
So, guys at home, Jody and Merrick, you should be able to see what he was talking about, HD2. So you can see there's quite a bit of a cliff here. For those of you watching at home, stand by and I'll... Your inset picture now should be what we were talking about, HD camera 2. So the vehicle has 9 cameras on it. There are 4 situational cameras, HD 1, 2, 3, 4. So HD 1 is looking sort of at the science camera and forward. HD 2 looks down at the sampling tray and both arms in view, as you can see now. HD 3 looks behind the vehicle up at the umbilical. And the HD 4 looks on from the right side of the vehicle towards the science camera. And then we have a quad view which shows the bullet on top of the vehicle and below the skid. And then the 2 main cameras that you typically see are the science 4K camera and the HD situational camera, which has a tilt function to it so they can look up and down.
Yeah, so Debs, we're in a... So I'm going to fly out of it.
Okay, so they're just talking about
management purposes.
Being in a bit of a... Yeah, so see where you are on the map there? You kind of have gone into that. I would say back yourself.
I can't back up.
Oh, you can't back out.
That's the back right there.
Right, because you're now parallel to the wall. So if you spin...
Yeah, but I just got to keep my umbilical from drifting over a wall. So I got to keep that behind me and try to come up out of this.
Okay. So we'll just keep rising then.
Yeah.
Till we're up over it.
We're clear on the back now, so I can keep coming to the... I can come to the port. What is that? Alright.
So, what does it remind me of when I was mountaineering, climbing up these snowy slopes? It's very similar, white snow and rock and vertical.
That's now on ROV if you need to talk to the bridge. There were some questions at home, I think, about our exercise and sort of showing our PIs, chief scientists at home, how we set up for sampling. We are not doing any sampling on this expedition. You are correct, we do not have a permit for it, but there is an expedition that's coming up towards the end of July, beginning of August, that we will be sampling on. And so some of the same scientists that are right now working with us virtually from their homes are going to be joining us hopefully on Falkor for that expedition. And so this is a great opportunity to have some early discussions with the ROV pilots on how we operate here on Falkor and potentially what they can accomplish with sampling for the next expedition.
Yeah, that's right. It really, just to reiterate Debs, it really helps us think about how we would design a sample strategy and what sorts of situations and geologic context or the shape of the seabed that the SuBastian is able to operate and sample within really does help us think about that. So I really thank the ROV pilots for that.
Like some beautiful corals there.
We're just setting up to take a look at them, so hopefully we'll get a little closer look with the cameras here. This looks like 3 different corals here.
Yeah. Just fractionally to the top right in the little black square, there was a little white thing there while I'm hunting for carnivorous sponges.
Okay, when we zoom back out, we'll try to see if we can...
Oh, you don't have to zoom back out there. Okay. See that little black hole in there and this little white...
Oh, the one in the little crevice. Can you zoom in, Ben, to that black spot in the crevice? Up here? I think it's actually just the color of the crevice. There looks to be a little bit of a white coral in there.
Oh, yeah.
I think Merrick was hoping that was a sponge.
Something like that.
So is that carnivorous sponge that you're looking for? Is it black coloring?
No, it's usually white.
Okay.
But I think you're right. It could have been old
So Merrick, can you explain to me a bit more about these carnivorous sponges?
Well, sponges generally have always been filter feeders. Same as like the octocorals there,
right?
Just taking the nutrients out of the water. But down the bottom of the ocean, or here and deeper down to 4,000 metres in the flat of the ocean, because food is so scarce, some of them have decided to switch over to a carnivory-like lifestyle, and so they'll sit there on the bottom, and then once every, who knows, every couple of days, every couple of months, might even be every couple of years, before a little crustacean like an isopod or an amphipod crawls over them. And they have these sponges are made of glass, it's silicon based, and they've got spicules, and most of these are microscopic. And for these particular ones that are carnivorous, they're probably about 3 to 20 microns in size, and they're really sharp hook shaped. And all these little isopods are big and hairy, and when they walk around, one of these hairs gets caught in all these thousands of these little sharp peely, and they get caught, and then the sponge basically, sponges are really cool because they're what you call totipotent. Like each cell can become any other cell. They're like stem cells. So what the sponge then tells one of its cells, okay, you're gonna digest this now, and so it becomes a digestive organ, and it digests the animal. So it's just an adaptation, or it's an evolutionary change that they've gone through to cope with these conditions. As you see down here, there's not a lot of life, so that's why they're switched over to that sort of lifestyle.
So are they doing just the carnivorous feeding entirely, or are they also doing some filter feeding?
They've just switched over to carnivorous behaviour totally. That's as far as we know. I mean, I keep looking when I get new samples to see if they do have aquiferous channels or things like that to show that they're halfway between the two. And there probably are some species out there that we just haven't seen yet. And because most of them are small, most of them are about 1 centimetre long, but some of them are up to 30 centimetres in size. You can see why they've easily been missed in catches before. And that's why having an ROV now is just fantastic, because we might be able to see some of these, and then we're allowed to collect it, go, yep, and now we can know what it looks like underwater as well.
Right.
that's what I'm getting excited about. So I've never seen one live yet in my life, so it'll be the first.
So you're on the hunt.
Yeah, I'm on the hunt for sure. And pretty much, if we see any carnivorous sponge, without a doubt, it'll be a brand new species. I went on another cruise on Investigator in 2017, and I've just written a paper describing 17 new species. Basically, everyone pulled up, new species, new species. And we found 2 species that have been described before, but 17 new. So 17 of the 19 were new ones. So
that was sampled by rock dredging?
No, they were sampled by, we actually put our Pacific trawls at 4,000 metres along the bottom of the ocean and at 2,000 metres halfway up the slope. So wasn't that beautiful, stunning coral reef. Because we're putting basically a trawl net, like sort of trawl net to run along the bottom, we had to find an area about the size of a runway strip that was flat enough that we could run this over. Otherwise, if it hits all these boulders and everything, they basically get snagged on the boulders, and then you lose $50,000 worth of gear straight away. So it's hard enough trying to find it at the same height and at a flat enough spot that we could trawl on. Yeah, and that's the great thing about having an ROV. You can just get into any spot you want and select exactly what you want. Yeah, and it's good because we went to all these, same as here, we went to all these other new marine parks off the east coast of Australia all the way down to Tasmania. And basically, they've been made into brand new national parks, but no one has any idea what we're actually protecting down there. So, same as this all this life down here is just basically new to science. So, it's fantastic. Can you control manual focus on those big cameras?
Yeah, the 4K camera has you can actually you can do manual focus, autofocus. You can do manual iris, manual ISO, or auto. So we have some adjustments that as we zoom in and look at different things, you can focus. You typically have to sort of put it in auto, then try to zoom in on the coral, and then take it out of auto and manually focus in order to be able to get the actual individual polyps.
Sure, yeah. Big problem I always have to do. I have all these automatic cameras, and I just want to focus on the background. So whenever I get knocked coral like that, the camera refuses to focus on it. And I go, I need a manual one.
Looks like another starfish, and maybe another sponge. Are you guys okay if we can
sign off? Sorry, the girls are getting somewhat restless, so I'm just going to have to sign off for now. But I will try and dip back in a bit later as you get a bit shallow up into the mesophotic zone.
Okay, great. Thanks so much for joining us, Jody, and say hi to the girls for us. We are going to just keep moving here at a little bit faster clip now. If there's something, Merrick, you really want to see, then shout out, but we need to cover some ground if we're going to get to the top of this today.
Yeah, no worries. Good. Good.
Thanks a lot, Merrick. I'll talk to you soon.
Okay,
thanks, Dad.
Bye.
Thanks, guys. Appreciate it. Bye-bye.
I'm going to make a quick shout out to my parents, John and Kathy, who are watching. Happy Mother's Day, early Mom.
Happy early Mother's Day, Deb's mom.
Chris says happy early Mother's Day, Deb's mom. Yeah, thanks. Happy Mother's Day to all of you in Australia today, and for those of you in the other parts of the world tomorrow. We appreciate and thanks all the moms out there for all you do. We wouldn't be here without you.
So thanks to Monique, my partner, she's looking after our little 1-year-old at the moment, who's unfortunately probably teething and getting up at like 6 times a night at the moment. So he's having sleep now. That's why I've got a chance to chat on, but he'll probably come alive at close to midday.
Good, yeah. One is challenging. I have a niece at home who just turned 2, so we all went through that.
Really interesting, like, weathered looking shapes there, isn't it? Much less angular, much more rounded.
Yeah, the rock here is really interesting too. It's gotten more like full-on rock versus the layers. I'm actually going to show you guys at home the ROV co-pilot display so you can kind of see the relationship to where the vehicle is. Ben, do you mind zooming out on your screen for a minute? Perfect. So this is what the pilots look at, and you can see the individual yellow dots are our intended waypoint track. You can see the red circle with the ship underneath it. That's our sort of danger zone. We don't try to get within 50 meters of the stern of the ship, obviously, while we're diving. And then you can see the yellow square is SuBastian. So we are moving our way north along this ridge. And looking at some beautiful geology as we're doing that.
We go hitting a biodiversity hotspot here.
Yeah, it looks really good.
The wall, yeah. Come back another day.
We'll take a quick look, quick pictures.
Yeah.
Keep moving. Yeah, this looks like a better wall. Maybe the current direction here for this wall is better.
Yeah.
Looks like quite a bit of biology.
Oh, beautiful. Beautiful. Oh. Look like gold corals there.
Yeah, that looks good, Chris. It gives us a good overview of the biology as well, having that sort of zoom out look. So that's fine if you have to back off and move up.
Yep, this is sort of place I like to go for a dive. So is this on the edge of one of the gullies, or is this overhang bit that hit?
Yeah, we're just sort of kind of coming where that, I'm not sure if you had a chance to look at the Multibeam yesterday, but where we're in sort of this area between sort of a slump on the side of this reef. And so we're just coming up to where that sort of slump part ends, and the sandier part should be coming up here soon of where the slope as we come up the reef. So we're just on some little bit steeper slope. I think I might be able to show you on your screen it. 1 second. If I change your camera, Merrick, I'm going to change your camera real quick and what you're viewing from us, and see if I can show you which one it is. Oh, and I have to change it back. 1 second. So the vehicle is, the white track is where we've been.
Yeah.
So for those of you at home, you've seen this fleeter mouse. I'm just showing it to Merrick, who hasn't had an opportunity to see exactly where we're diving here on this fleeter mouse overlay. So we're just working along that ledge there.
Along the top of the edge,
And then,
okay, that's great.
And then we'll at some point here when this starts disappearing, we'll jump and work up, and we'll probably do this sand bit quite fast, and then hopefully come up to this top ledge here and have some more time to look through those layers.
Yeah, great. No, the ledges, vertical surface definitely make a difference for the biodiversity. Thank you for that, Deb.
Yeah, no worries.
It's the same as when we go diving for sponges, scuba diving for sponges and oxbows. It's when you work out with the sounder and find the most relief, and always go diving there. It's always so much more fruitful. That's our sort of biodiversity.
Yeah, it's been our experience as well in most of these different expeditions that, you know, if you can find a little bit of current but not too much, and if you can find more rock face, then you tend to find more biodiversity. It's always very interesting. We've had a number of different scientists come on expeditions where they've actually looked at the flow of current around rock features and features on the seafloor and which side coral end up connecting or living on, and it seems to be quite important for them to be in that you know, more flow environment, but not too much flow, and to be able to kind of have some food and definitely a rock face to connect to.
Absolutely, yeah. Those conditions are critical, yeah. So it's interesting little white bits as well, which might be back to next coming out. Stunning.
Yeah, there's a bit of a cliff.
Up on the mountain.
Bit of a cliff face here that we're going to start climbing up and start working our way up to the, unfortunately, sedimenty area, but but Chris is very interested in this crack, so we're going to look into it.
I don't think you're going to be able to fit in.
No, we can't fit in there. Do you think so? Oh, yeah. He said we would, but we wouldn't be able to get out. That is a pretty cool crack.
Oh, there's something hanging out on the edge, that little white thing there on the left-hand side, yeah.
Yeah, it looks like some coral on the outer side of this crevasse.
It's a color, isn't it?
Color? I don't know. I'm not a geologist, so if I'm saying the wrong terminology. Background in marine science. Background in marine science and 15 years of hydrographic surveying, so shallow water.
Wow.
So this is definitely different now with this deep water is really cool. You can cover a lot more area with a big ship and a deep water sonar.
Yeah, sure. Did you find you got a lot of current around Osprey? Because you can easily get greater than 4 knots underwater down there for all the...
I don't think we did really on that dive. I think...
Hi,
yeah,
James Merrick, back. This is Robin Beamer calling in from Cairns, about 300 kilometres away from where the Falkor is, and going over a really big crack split in the rock here. It's quite dramatic.
Yeah, you can see there's a boulder back there.
Yeah. Shock zone.
So what depth are we now at, Debs? I don't have the overprint.
We're at 780 meters. We're just working up our way. Here, I just showed Merrick, but I'll switch your video real quick so you can see where we are in Fledermaus. stand by. That's our, for both the PIs, this is our event logging system. That's all on the same system that we have Fledermaus. So here you go. We are just start climbing up this I'm assuming this little divot here is this crevasse that we're working along. So we're gonna fly up over the top of this here, and then work our way up this last set of waypoints. So we're starting to try to work our way north as well as to the east.
Yeah, thanks, Deb. That's quite clear now. So for viewers at home, this was chosen because it was, I guess, the right-hand scarp as you're looking towards the reef of an undersea landslide, and it's at least, this landslide in horizontal distance is at least 3 kilometres long. Maybe you could zoom out a little bit more, Debs, just to...
Rob, you're the only one seeing that.
Has collapsed.
Rob, you're the only one seeing that.
All right.
I can add it too.
So
Hold on. I can add it to everybody at home if you want to talk about it.
I can talk through.
There you go.
Yeah, so the South Flinders Reef in distance is around about 16 kilometres at its longest width, and about length, and 6 kilometres wide at its narrowest. So that big dark area in the middle, that's where the coral reef, the shallow coral reef is itself. And you can see this quite distinct face on sort of coming out from the middle. Well, that's the left-hand side of the scarp. And the right-hand side of it that we are flying up with the ROV is the right side of it. So everything in the middle has collapsed, and you can even see the remains of big boulders that have they're now stranded at the lower reaches of this coral reef. So the bottom there is around about 1,000 metres depth. The whole reef itself is about 1,000 metres high. It looks like we're about we're part way up this wall now. The early part of the dive, we were flying up a very steep scarps, about 100 metres high, and now we're almost at the top of that, and we're going to start working our way up towards the shallower Mesophotic zone.
That was great. That was really cool. I like that. Now we're out of it. Yeah. Again, it makes me feel like I'm mountaineering with all that loose ice and rock above you, just waiting for boulders to come screaming down, and you've got to move through those areas as quickly as possible out to the open.
Yeah, guys, so we're just getting up. Sorry, Merrick, I don't mean to interrupt. I just want to let you know that we're just starting to get up on top of that, out of that crevasse and on top of this sort of more moundy sediment area, and we're going to scoot along pretty quick so we can get up to the next step ledge area of the reef.
Yeah, no worries.
Yeah, thanks.
So that was great.
Thanks, Deb. And also to Ben, Russell and Chris, our ROV pilots in the operations room. At some point, Debs, would be great just to show a camera from inside the ops room so that people can see what that looks like. It is literally like flying like the cockpit of an aircraft with lots of monitors and people with joysticks and many monitors everywhere to try and keep a sense of where we are. But the ROV pilot's doing a great job flying up the side of this very steep reef.
Okay, so this is the science control room on the ROV Falkor. Everybody can say hi. There's Russ and Chris is flying. Russ and Chris are going to pass off. It's lunchtime here in Australia. So that's a ROV pilot handover. And Ben is running the winch and the camera, and I'm over here on the control. And then if we swing the camera around a little bit, You can see, say hi, Jimbo. You can say hi to our lead tech, Jimbo, and he's running some of the video recording and event logging.
Oh, that's what I want. All the sponges under there, glass sponges. Everything. Black corals. Even black coral as well.
Merrick, I'd just like to let people know that we've got an expedition planned in a few months' time where we will be using the arms of the SuBastian to collect samples. I'm just curious, from your perspective, collecting these glass sponges, how fragile are they? Are you confident you'll be able to get a whole specimen, or they wouldn't just crumble? So I'm just curious, what would they feel like when you're picking them up?
Well, some of them are, if they've got a really strong matrix, some of them are quite strong and they're like a solid bit of rock, but other ones, like the one we had a big cluster of about a dozen of them before, will be like picking up champagne flutes. So, so we'll see. Even if we get fragments of them, we can work out what they are, but of course, the whole specimen's better. And it depends, if they can cut the rock out from around it, then obviously you're more likely to get them all intact. But the good thing about having the ROV, we have this, and we'll get some fantastic stills to go with it as well. So even if they get fragmented, you can still work out the whole shape of them. Whereas in the past, if something came up from a dredge, you went up the fragment of it, you still had no idea about the whole shape of it. And some of those carnivorous sponges I've just described, they're in the same boat too. It looks like you've got half the tree of it, but you can never tell whether you've ended up with just one branch if you didn't get the whole thing. Whereas a lot of the other times, if you look at the octocoral on the bottom left, you see it's got a nice hold fast on it. So if you get all that, then you've got the whole thing. And they're those glass sponges we were talking about before, the ones that look like cylinders. So those ones will be extremely fragile. Whereas the ox corals are quite stable, like the one on the bottom left of the screen there. If you grab that whole thing, you'll pull the whole thing off with the hold fast as well. Oh, look at all that life, isn't it great?
Yeah, this is a really nice wall, isn't it?
It is.
Lots here.
I would just there's black corals, there's octocorals, there's sponges, there's worms.
Yeah, just want to reach out and grab.
Oh, you do, don't you? Like
well, for people listening, we will be doing this. We will have permits, and the next expedition allow us to collect physical samples. Those physical samples they'll end up at the Queensland Museum, from which they'll be, whatever samples will be passed out through taxonomic specialists around the world.
Oh, that's just stunning, that bit. Excellent.
So I might just mention expedition that I was on last year to the Coral Sea. It was up to the Tasmantid seamounts, which is at the very, very far eastern side of the Coral Sea Marine Park, same park that we're in at the moment. The Tasmantid seamounts were formed by extinct volcanoes now. There's a line of them. It's similar to a hotspot chain that created the Hawaiian seamounts. So in Australian waters, we have something similar. It's called the Tasmantid seamounts, and the tops of those are coral reefs as well. That was a more geological expedition, so we were putting rock dredges down to quite deep depths. I think we got to around 4,000 metres at times. Unfortunately, we didn't have any cameras, but we were able to bring back rocks with sponges attached. And at times we collected these sponges that you're really interested in, Merrick, with these long glass spicules. In some cases, over half a metre long. The first time we pulled them up, I thought we'd actually cut through a fibre optic cable, internet cable on the seafloor, because that's exactly what they look like. They're sort of long spiral, almost finger thick. When they're all spiral together, but just beautiful long pure glass spicules twisted together, just like an internet cable. But of course, they're just sponges.
What do you mean, just sponges? But of course, yeah, you're right. You end up with like 100 filaments of similar in size and to a fishing line, isn't it? And they're all, like you say, in a nice, beautiful helical coil pattern. So it looks so well constructed, and it is obviously, but each one of those is a little cell. Yeah, there's another glass sponge. Yeah. That one there is much more rigid. Will come up together as one piece. But it's still sort of fragile. If you drop it, it'll definitely smash. In the same way that if you dropped a coffee mug, it would. Oh, look, see this one coming up? It's the base of that whole stem that has those multi-strands that you're talking about. It would have been one of those that you cut off, and in there will be like 100 strands looking like fishing line all put together.
Yeah, but we never actually got the top of it.
Yeah, that's a problem with a lot of these. You don't, unfortunately. As you can see, the top bit is made of glass, but it's really soft glass. It's like it's more like fiberglass sheet matting, and so when it's pulled up, unfortunately, all the force when you bring it up from 4,000 metres, you're going through a lot of water, a lot of hydrostatic force on it, and unfortunately they get washed off.
Yeah, that's why that it was mixed up with rocks. That's right. And they were completely smashed up. So we never. What's the top of it called? What's the proper taxonomic name for the main part of the animal at the top?
Yeah, well, we actually call that the body. We call that the body of the sponge, because that's where all the organs will be. Whereas the stalk is basically, usually just for support. But of course, it has spicules all on the side there as well, and you can see this one's colonized as well. But yeah, the little bit at the top. Sometimes it's really small compared to the size of the sponge. It's the actual body of the sponge, where all the organs and the reproduction and the digestion goes on. Yeah.
So it must be pretty amazing physiology that, like, the bottom cells are extruding these long strands to create the stalk that's sits on. That's
and
pretty remarkable.
Yeah, and each one of those bits of glass, that's what they are, solid glass, and they're actually purer than fibre optic cable, and they're hollow too, even though they're, in this case, they're 0.5 millimetre in thickness, but the centre of that will be hollow. And it's just one entire cell that the sponge has just created. And so you're talking about the ones before that were like where you actually get one single spicule that's up to 1 metre long. So a bit of the glass, they're about 3 millimetres thick, and they're all hollow as well, and you can actually flex them, but not too much because they'll break. And there's just one species of those, and I'd love to see that underwater, but I've never ever seen it underwater too. That's one of the few ones you can identify straight off. There's only one species in the genus that has a massive big spicules. So, yeah. Oh, sponges are really cool. There's a dead one that's fallen over. They've been around for 500 million years.
Nature's glassblower.
Yeah, exactly. They've been around for over 500 million years, and sponges will be around long after us humans are gone. So, yeah.
So you can see the strands of the silica fibers splitting apart.
Yeah.
But the animal, the head of it, the main body, that would still be alive, would you say?
Oh, no, I don't. I think so. The fact it's on the ground like this, I'd say it's died. But, yeah. But being solid glass, it's going to... How long do you think the glass is going to take to break down at the bottom of the ocean then, Rob? Might be there for 1,000 years, 10,000 years, 100,000 years.
Well, it could take a long time, but it would, it would break up. There's wave action. I could actually see that waving around the current.
Yeah, that one.
Anyway,
yeah,
so eventually it would break up, but it would just form part of the sediment. That's something we'll be interested in doing this expedition. The geology, the sort of ancient geology rock, but we'll also be doing sediment samples. So doing push cores. The SuBastian can do this, literally go down like a geologist with almost like a rock hammer. You can smash off a bit of rock, or you can actually suck up a little bit of sand, and from that sand we can tell a lot about what's raining down from above and the composition of the seafloor. So we look at texture, geochemistry, grain size. It can tell us a lot about the whole environment these animals are living.
Yep, that's not a beautiful glass from the same species, and it's got
brittle star.
A couple of brittle stars on it. Yeah. Making use of something to get them off the sediment. Yeah, well, that's really true, because sponges, because of that silicon nature, are well represented in the fossil record. And the other thing is they make up quite a lot of the sediment and other things. Particularly, a lot of sponges will pick up these old spicules and take them in and use them as armouring, or even take them into their tissues and use them as structure. So, because they don't make them themselves, or they prefer to use their energy elsewhere. So they're very, the glass is very resilient. Stays around for a long time.
It certainly is. I've been down to Antarctica a number of times, and when you look at cameras on the Antarctic seafloor, where there's a lot of silicious sponges in the shallows, they can actually, when they break up, they create these dense silica mats on the seafloor. Like the sediment is actually mostly silica spicules from the sponges that are actually broken down over time, and they form these very, very thick layers. It's very hard to punch through them, but quite unique, really interesting to see in Antarctica. You see, because it's much colder there, most of the sponges there have a silica spicule base.
Yeah, and well, thanks for the pilots there. That was fantastic, stopping and looking at those sponges. I just so want to go and grab them, but we'll have to wait for that. But well, down at the bottom of the ocean, there's 150 times more silicon in the water than there is at the surface of the water. So that's another reason why these sponges are using all that silicon to form their bodies with. I mean, all sponges, well, most sponges, there's a group of sponges that don't use silicon as part of the skeleton, but basically all the other sponges do. And silicon's widely available, and especially at the bottom of the ocean. You want something rigid to be able to grow out of that, above the sediment, to keep away from all the snow.
It's interesting to see all those other commensal animals growing on them, living on them. It's fairly common. We're seeing lots of brittle stars and other like shrimp and the like. They're using every opportunity to get higher up out of the water column.
Yeah. Oh, that's great.
Because the closer you are to the seafloor, look, that's a good view there.
Down the osculars down the front. Yeah, they're the exhalant part of the sponge. So these ones are filter feeders, and that's where they suck the water and is using microscopic type things, and they'll expel the water out to those big ones. And you'll often find a lot of things like shrimps and that hanging out in there. And so to a sponge biologist, we aren't interested in the sponges, aren't interested in the shrimp, so we'll throw them away. In the same way that we go, there's a rock, pull our sponge off and throw the rock overboard. But you, of course, would throw the sponge overboard and keep the rock. So we all have our own little particular interest, don't we?
Yeah, we do. But just talking about animals that live inside these sponges, probably the most well-known one is the Venus flower basket. Do you want to talk about that? How they're used? What animal lives inside them?
Yeah, the Venus flower, otherwise known as Euplecta. It's a glass sponge. It forms a beautiful lattice thing, and it's about 6 inches long, and that's why it's called a Venus flower. And what happens is two shrimp, a male and a female, go in there, and the sponge forms the whole time. It's hollow, a hollow tube, and it looks like a cage. And the shrimp go in there when they're young, and as they develop, the shrimp grow up to not quite an inch long, but the grid of the skeleton is probably a 3 millimeter grid. So they can't ever escape in there. And they believe that the sponge and shrimp might pass on different nutrients to each other. And certainly the sponge provides a protection housing to protect the shrimp. But and so when they develop young, of course, the young can escape. And so a lot of cultures, particularly Japanese, these glass sponges are given as wedding gifts because it symbolises the two of you together through marriage and through the rest of your life. And you can buy them, I believe, about $200 online. But I've never seen one live underwater, but I've seen ones that are several hundred years old. And there's a nautilus shell down the bottom.
Yeah, great. We've seen either dead nautilus or live nautilus on just about every dive now, except perhaps I think the South Osprey Reef. Anyone who's been watching or following this expedition would have seen the live chambered nautilus that we saw at North Horn. I think we ended up counting about 18 of them in the end. And during the daytime, they live in this zone between around 700 to 500 meters. So that, they're living, they're bobbing around. They're scavengers, so they're attracted by the lights or noise of the ROV. And at North Horn, they were really numerous. We've seen nautilus shells at Holmes Reef, a previous dive to this one too, although we didn't see any live ones. But Andy Dunstan, who is a colleague of ours who did his PhD on chambered nautilus in the Coral Sea, he says it's just a lack of sampling that we just don't know exactly which reefs have got them. But he said that it's very likely that they're on all of them. So far we've seen shells. Clearly they live here. They would have, as they died, the chamber would have filled up with water and then fallen on the seafloor. But just talk a little bit more about their life history. So during the daytime, they're in this zone between 500 to around 700 meters depth. But at nighttime, they migrate vertically upwards. So they swim a couple of hundred meters higher up into the water column at nighttime. So as sun starts to set, they go up to around that 300, 250 meter mark where they do their feeding. And then at the end of the night, as sun starts to rise again, they migrate back down into these dark waters. So these chambered nautilus are swimming at least 200 meters twice a day. And it'd be great to be able to see some more of them here. There's no reason why they shouldn't be. The water's exactly it's very similar to what it was at North Horn at Osprey Reef. So the nautilus species is actually Nautilus pompilius. That's the species in the Coral Sea that we're looking at here.
Nice Siri antipathies for Jeremy. Probably got that one. Probably quite common.
Yeah, really long. How long do you think that would be? It looks like at least 1 metre long.
Yeah, I'd say between 1 and 1.5 metres, something. They're
So
hard
one
to
of the
store because they're so they get quite fragile. They can snap. They've got a bit of flex in them, but
we have Jeremy
find a jar
Roberts.
of ethanol or metre long.
Yeah, so Jeremy is a principal investigator on the next voyage. Jeremy's a PhD student at James Cook University, and he's working on the taxonomy of Antipatherian black corals. We will have a permit so that Jeremy can collect these deep water black corals, and also the black corals that we might find in the Mesophotic, the twilight zone that's a bit higher up in the water column. So any fish specialists watching, that'd be really great to get a name on this fish. Really quite amazing looking. Okay, I'm going to throw a suggestion in. A coffin fish. A pencil coffin fish. Let's see if anyone can come up with a better name.
Is it a toadfish?
No, it's not a Diodontidae. It's definitely not a toadfish.
Good suggestion.
Yes, grumpy fish, I agree. I threw in that there could be pencil coffin fish, and that's really just from work that we did in the German Deep Down Under voyage in 2009. We reached out to John Pogonowski, who's a coffin fish expert. He gave us that tentative species name. So anyway, if anyone knows something different, happy to take advice from any experts ashore.
When did John give you that? Did he just come in online then, or you'd be the master of what's down there in the deep ocean? He was on the expedition we did off the abyss of Australia from Tasmania up to the Coral Sea. He was identifying the fish on that.
Some very nice layering going on here. So strata. I mean, when you look at, in fact, it's like shallow coral reefs on the edge where I've scuba dived. This is kind of strata you get. This, distinct layering effect. It's not always horizontal. It can be all over the place. But the whole coral reef itself, this big South Flinders Reef, is 1,000 meters high. It's 1 kilometer high, and it would have been. It's simply developed shallow coral, and as the plateau has subsided, 3 big pulse events over a 20 million year period, the corals themselves have grown and managed to keep within that photic zone, which is so important. So much so that even now that the general plateau is 1,000 meters deep, the coral base has grown up and continued to stay close to the sea surface where that shallow light was. And now we have this, this distinct layering effect. So I would say those rocks are actually made of shallow water coral. Of course, no tropical, sunlit shallow coral water corals are growing in these depths now. We're just looking at the remains, the fossil remains of them, each layer growing on each other. And as we go higher up the wall, the flanks, each layer just gets progressively younger and younger in time. But it's very likely that these corals are several million years old. The last big subsidence event happened 3 million years ago, until we get right up to the top of close to the reef itself. So it's fascinating to see all these different layers.
Just having a quick look at some of the reports from the deep sea ocean. Sea toad, Shornax, which is what someone just suggested before. I think looks like the winner. So well done. Another beautiful octocoral, something similar to a Norella species, possibly. Again, you have to look under the scanning electron microscope to work out what they all are. Nice bit of getting a bit of structure here for things to be able to hide in, things to grow off. There's our toadfish again, as someone previously said it was.
Yeah.
I know nothing
almost
about
has like
fish, so.
it almost looks like it's got hands, hasn't it, for its
yeah, like
actual fins.
Well, I think they do virtually walk around on the ground anyway.
Yeah, it has that grumpy look about it, though.
That turn now. Eh?
Yeah, great flying by ROV pilots there. Just going over echia and worm proboscis. These quite commonly seen now. They're bottom dwelling, obviously. Their main part of the body is usually under rock somewhere, but they lay out these very long proboscis, splitting sort of almost a Y or T shape, and they're draped across the seafloor. They're deposit feeders. As food drifts down from above or is found on the sediment, it just sticks to the proboscis, and they can bring that proboscis back into the animal. There's another one coming up on the left-hand side. Now, if you follow that in, it's coming from usually under rock, but we've seen this quite commonly on the other dives. Yeah, thanks, guys. It looked like the body was at the higher end of that. There's another one. You can see that it splits. It's like a Y shape. That's the end of the proboscis, the actual animal sitting in the sediment within a burrow. Like if we were to bump that or touch it, it would probably withdraw. But here on the deep ocean, they can be quite long, several meters long. So once you get your eye in, it's starting to move now. Looks like it's slowly withdrawing it back into the mouth. So the original animal, the main part of the body of the animals is in a burrow within the hole, and it's now pulling that proboscis back into the main body. It's quite slow.
Yeah, I just saw on one of the feeds someone was asking about the name of those glass sponges. We kept looking at all the beautiful ones. They're Hyalonema. Anyone wants to look it up? But I'm not sure if there's any images of it on the web. But it's the type of sponges they are. So yeah, they're fascinating. Oh, look at how many worms there are there. Yeah.
Yeah, lots of echia worms. This is a very big sort of T, almost Y shape. They split at the end, they bifurcate, and they're just basically sticky threads that food can that falls on or attach to, and then they just withdraw it into the main mouth for the body is actually inside the burrow.
Yeah, and they're several meters long, stretching around. And they can withdraw them quite quickly. Yeah.
Yeah, great. Another nautilus shell coming into view. Looks like it's lost most of its colouring, so it looks quite old and bioeroded because any calcareous shell is very quickly colonised by polychaetes and various worms and all kinds of animals, bacteria breaking it down. So if you recall, the other one we saw had lots of colour on it, so more recent than that one. But anyway, good good flying guys. Our ROV pilots are Ben, Russell and Chris, doing a fantastic job flying up the side of this reef.
Not a toadfish, but me being a sessile marine person, I'm much more interested in the organism behind it. That's what it is. So we want to get 2 for the price of 1. Nice to have a bit of colour down there, isn't it?
Yeah, it is. And I guess there's looks like a spider crab. We're just going over. Can we get a bit closer to that spider crab, please, guys?
It's a bit better camouflaged.
Can you bring up the laser beams just so we can get a sense of scale, please? Our viewers will see these 2 little dots down the bottom of the screen. They're 10 centimetres across. So this would be sort of roughly 20, maybe 20 centimetres, probably much wider, maybe in 40 centimetres with its larger legs, its chelicerae out wide. Quite a fierce-looking animal. Thanks very much, guys. Great flying. We have seen spider crabs before. This is our 4th dive. We've done 2 dives up at Osprey Reef. Someone asked, are we going to see live nautilus up there around here? And I mentioned earlier, there's no reason why we won't. But we do know that North Horn at Osprey Reef, there's a fairly large population of them. We did see, we counted about 20 of them in the end. And so there's no reason why we can't see them here living as well. So we're getting to this, as we go up, we're around about that 500 metre mark. Temperature's definitely warming. We're now about 9.2 degrees Celsius. We started the day at about 1,000 metres down. It was 4.5 degrees there, so quite cool. We're still within this cool water zone, but we're rapidly approaching the thermocline that sits sort of around that 500 to 400 metre mark, and that delineates the subtropical mode water that we're sitting in with the warmer sunlit waters above. So pretty shortly, within the next hour, we're going to go through this thermocline. Anyone who's listened to Tom Bridge before, who was speaking, this is quite a distinct thermocline that sort of separates this cooler animals, the cooler biota below from the Mesophotic and above. So once we push through this zone, probably in the next hour, we'll definitely be into that lower Mesophotic zone. But what we find is this section here tends to be a little barren of marine life. It's just a little too warm for the cooler water animals to live there, and a little bit too cool for the tropical warmer water animals to push down. So it'll be interesting to see what we get through there. But once we're through it, into around perhaps 350 metres depth, we'll start seeing a lot more soft corals again. So it's good to see this pattern occurring on all of the reefs that we visited. It's the main reason why we've chosen to have these long vertical transects, so that we can understand the depth zonation against the marine life that we see there. So the beauty of having the Falkor out there is they're collecting these wonderful three-dimensional maps from Multibeam echo sounders, so we get a really good sense of what the topography looks like. And then we plan a dive over what we think is the most interesting area. But the idea is these long vertical transects, so we can make sense of the changes in the biology as the environment around them changes. And just so viewers are aware, there are no scientists on board the Falkor at the moment. It's embarked with just ship's crew only, very competent ship's crew, of course. But because of the COVID crisis, we've all had to stay on land and do the best we can to communicate with the ship and plan things ahead of time. So communication is challenging, of course, but it's been very exciting to be able to watch the progress of the expedition. Myself, I'm speaking from Cairns, northern Australia. I'm about 300 kilometres away from the ship where it is at the moment. Dr. Marek Eakins is from the Queensland Museum. He's based in Brisbane. And we've had Jodie Webster from Sydney on today, as well as Tom Bridge, who's in Townsville. So we're all doing the best we can to try and contribute to this this great voyage of discovery, visioning the Coral Sea Marine Park. So just talking about the geology for a moment, looks like we're going over a big rubble zone. So coral rocks that have just broken off from higher up on the flanks and have all like a big debris zone, and now they're all coalesced together, forming a conglomerate of carbonate rock. So we're seeing sort of a whole different lots of geology here, strata, layers, different layers of coral growth. This is old fossil limestone, and intermixed with big boulders that have tumbled down from above, all of which is draped with carbonate sand that's drifting and draping over the top.
It's like a real scree slope there, isn't it?
Yeah, definitely, Eric. And if we recall, right back at the beginning of the dive, we actually planned the ROV dive to go up the scarp face, a big undersea landslide, which basically lies all the way to the left of the screen. We're now above that big scarp face, but it's left a big vertical wall of rock, really hard rock. It's the base of this particular limestone atoll, and it's nearly a kilometre high, but down around that 900 to sort of 800 metre mark was this very, very tall wall, just sheer rock. But it's quite interesting to see now we've gone above that old landslide scarp face, and there's still plenty of limestone rubble, all as you say, a big scree slope. It would be cemented together now. We're talking, millions of years that this atoll has been in existence. But it's interesting that it's quite well rounded. Geologists or sedimentologists can tell a lot about, I guess, the environment that these grew in just by looking at how rounded they are. So they're clearly eroded, but they're jumbled together, and just a big conglomerate mass of debris, rocks and debris.
It looks to me like it's going to release and then you knock it and it'll all fall down, but I think it's more cemented than that.
In these waters, it really doesn't take long for coral rock to start to cement together, and this is just the organisms, algae, and things like that. We often say things like coral is the bricks, and the mortar which binds it together is the coralline algae. I can walk along a tropical beach here off Cairns, and the coral rubble that's washed up onto the sand a year later can be solidified. It's called beach rock. You can actually see the individual coral branches all cemented together, and that can only it takes place over a very, very quick time period. So, clearly there's places here that look a bit unstable, but I'd say some of those bigger scree slopes are very solid.
Well, that sort of features reminds me of what we call phreatics in caving in the limestone, when it all gets that water-worn look. Capture out there hunting.
Well, it's a decent size. It's nearly 10 centimetres long. So just from our laser beam. So yeah, it's quite a nice little gastropod there on the side of the rock face. You see lots of pitting and things like that. Now, in geological past, this may have been exposed at sea surface. So, subaerial. We can never really be sure about that. But Jody Webster, who's our marine geologist, he'll be on our next expedition. Well, he's on this one as well, but our next expedition will collect samples. We will be able to actually take rock samples, and we can tell a lot from just the geochemistry of these rocks, a lot about their past history. The animals that made it, like the fossil corals themselves, are just like were living libraries of the environment they lived in. As fossils, they preserve that within their skeleton, and you can tell a lot about the water temperature they're in, whether they're exposed to the air or not. And so it's very likely we'll be able to actually tell, whether these were subaerial or always underwater. And this is just simply erosion caused by, sediment, like these runnels that we see here. It's almost like a karst limestone environment. This limestone hills behind Cairns, and these are exposed limestone. You can actually see these similar sorts of runnels on the sides of that ancient limestone. So it'd be very curious to know, is the same processes happening here?
Where's that area you're talking about? I'm not talking about Chiligo, are you?
Yeah, that's right, Chiligo, which is an ancient Devonian reef. And you can see these limestone karst towers. Anybody who lives near limestone they have this similar sort of runnel effect. And that's usually because of fresh water, slightly acidic, and actually erodes the calcium carbonate limestone that make up those fossil reefs. Be very curious is that what's happened here on these coral sea atolls, because we know they're very, very old. They're at least 20 million years old, probably around the bases of them. And the most recent large growth period probably happened about 3 million years ago, as well as the more recent Holocene growth at the very, very top where the shallow corals now grow.
So are you saying these bits were probably out above the sea level and it was freshwater runoff during that effect?
Yeah, it's a hypothesis. It's quite possible. These, as well as subsidence periods, we're talking about 20 million years of fluctuating sea levels. And we do know that limestone here would have been shallow at some point. It's, of course, with the subsidence, they're now down deep where they are now. But, it's quite possible these would have been exposed at some point when sea levels were fluctuating during glacial periods. Sea levels can drop over 120 metres at times. The last ice age, 20,000 years ago, sea levels were about 120 metres lower than what they are now. And so certainly the tops of these reefs would have been exposed. So it's difficult to know at these depths if the same thing happened. But you're right, they do leave this sort of classic, almost karst-like erosion pits and runnels on the side like you find in fossil limestone environments on land.
Yeah, it reminds me a lot of the caves inside Chiligo. They're caving there. Beautiful phreatic sort of, that smooth, weathered look. Yeah. You can just imagine fresh water streaming down the edge of the mountains or cliffs at that point, aren't you? There.
Yeah, I agree. I guess this is the feature, the biggest factor with that fresh water is it is slightly acidic. It picks up that acidity just through falling through the air and carbon dioxide, and it turns into like a very weak carbonic acid, and it literally melts away the limestones, and that's how you get that sort of karst-like features. That's not to say you can't have this sort of thing happening all the way underwater as well. It would be sediment, though, just erosion. You can almost see the sediment building up, and preferentially follows the same axis time and again. And, over time it would cause erosion itself. But I wonder if the original the original factor was perhaps fresh water draining down the side, causing these runnels to create in the first place.
From a non-geologist look, to me, this looks like we're looking straight at solid limestone. But when we're lower down and we see the more blacky rock and sometimes in shells, is that the same sort of limestone, or is it? Can you explain the difference to me?
Yeah, good question. I mean, the thinking is that we are talking about the whole structure of this atoll, even if it's a kilometre high, is made up of shallow water corals. Of course, when they were close to the surface, they were growing, but as the plateau subsided, those corals built up. But it's not just coral. There's a lot of other material that can contribute to that. So we've seen boulder scree slopes, things like that. But you're right, this does look like just solid limestone. So one of the things we will do in the expedition coming up is we'll actually take some rock samples and we'll be able to confirm for sure is this limestone. What we do know, if we go right back into that deep geological history, the reason these reefs are here in the first place is they're growing on the upturned corners of continental rock, parts of Australia that broke up during the breakup of Gondwana. So when Australia first split off from Antarctica, coming away from that big landmass which we call Gondwana, Australia started drifting northwards at about 9 centimetres a year, and still does to this day. In fact, Australia is one of the fastest moving plates on Earth, and has been moving for well over 40 million, 60 million years. It's been moving northwards. And so the edges of Australia have split off, and there are these big continental blocks stranded out in the Coral Sea, and these ancient limestone atolls that we're now flying up have grown on the edges of these. So these are true atolls, but the base of them is actually continental rock, not volcanoes, not volcanic, not lava and volcanoes. Nowhere on the Queensland Plateau is there any hint of volcanic activity. So atolls can form on all sorts of things, and in this case, ancient crystalline continental rock. We're talking several kilometres deep. Then we only know this from deep seismic surveys that were done in the 1980s.
That's cool. Thanks, Rob.
So from a water mass perspective, we're definitely pushing up through into that sort of transition zone. So the water temperature is starting to warm a lot more now. So what we found in those other dives we've done on the sides of these atolls is we get that cold water coral community up to around 500 metres. Certainly when we're in that 400 metre zone, it's a real thermocline. It's going to start warming quite dramatically from here on. But we have noticed that there's sort of a lack of biota in this zone. So hopefully by the time we get to around that 400, maybe 350 metre mark, we'll start seeing the soft corals appearing. And really they'll just get more and more dense as we go higher up in the water column then.
Well spotted, guys.
So for our fish experts ashore, we'd really appreciate anyone can ID these. None of us are fish experts out here, so we welcome input from ashore. Anyone can identify these animals.
I'd have a little punt and say it might be a Parapercus, but I know nothing about fish anyway. So. Quite welcome for anyone to tell me that's way wrong. Oh, you can see a real coral.
Yeah,
broken off and fallen down. Yeah.
Okay, so this is classic shallow water coral, like a bigger cropera. It's lying on its side. You can see the base on the left-hand side, and then the main living animal, the polyps, would be on the right. Now, this is well and truly dead, but it just shows here around that 400-metre mark that shallow water corals, well, they will fall. It's just debris. And we've seen this quite often through these dives where shallow water material can only grow up in those higher sunlit waters, but they can fall all the way down to these very deep depths on the side. So this coral would not have been able to grow here. It had to have been right within that sunlit zone, probably in the the top 20, 30 meters of the water column.
I don't know if anyone noticed, but in the bottom right below that there was a bright little yellow sponge, a little ball, which we call, I love the name, it's called Cinnacara abracadabra, the magician's sponge. Yeah, down there, that's right. Move along, but yeah. 10 centimetres out from the coral. Yeah.
Are you talking about that little yellow sponge there?
Yeah. Well, I think from my screen, what I can see. Yeah. It's not a carnivorous one, so because it's shallow water, there's some black corals there as well. So.
Yeah, and a Pitheria on the right.
Yeah, lots of other things growing on that bit of coral as well, I imagine. Oh, that's nice. Thank you.
Oh, little cup coral. Yeah, that's surprising. So that I expect to see a bit deeper, but yeah, great. This is a scleractinian cup coral. It's just a solitary coral. It's not colonial, of course. You can almost see the septa separating within the corallite. It's quite an ancient form of coral, and certainly on the other expeditions that the Falkor has been part of in Australia, they've been very interested in getting those cup corals because just like their shallow water cousins, they record the environment in which they live in, and because they're living in these depths, the geochemistry can tell you about the temperatures and things up until when they died, and that all that is locked within the skeleton of the coral.
It sort of reminds me, if you've done much muck diving, when you get low visibility and you go for a scuba dive, you tend to focus on all the small lifeline that you don't normally notice. If you go diving, you've got a beautiful Pacific Ocean with 30, 50 metre visibility, and you're watching the turtles and the sharks and things going back, and you don't often see that small life, and it's usually when you get a low visibility dive, you're forced to look at things a foot away, and suddenly you notice this whole world of tiny little shrimps and nudibranchs and things like that. So it's just like then when we zoomed in there and we suddenly saw a whole lot of other things. And it's all stuff that's there all the time. It's fantastic with the ROV SuBastian and the pilots who can get in there and look with these amazing cameras too.
Yeah, I was just going to say that's what's so remarkable about the cameras on the ROV dive. It's not fixed. You get that wide angle perspective, which I really appreciate because I'm always trying to relate it to the 3D depth models that we've collected from the Multibeam. And then it can almost zoom in, like you just get that complete ringside seat of animal life directly growing on the seafloor. Actually, I can see a lot of halimeda. Halimeda is this green algae. There's little white flakes, so it's not just coral. It's coral rubble here. It's also halimeda, and we know this is quite a big. This green algae grows quite prolifically in the shallow water sunlit zone, so it's also drifting down from above. It looks like we're getting a lot more black corals appearing. Which you think these are black corals?
Yeah, I think they're black corals, but there's a whole lot of polychaete worm tubes in there as well. So, a good little niche habitat for that one species of black coral by the looks of it.
Yeah, so these sort of exploratory ROV transects are really helpful for us because if we understand this kind of pattern, let's say we're in this zone now where we're seeing a lot of black corals appearing, these long strand-like black corals. We'll have Jeremy Horowitz with us on the next voyage, and he's doing his PhD on them. So we'll know better where to go to target these because we'll be able to actually collect them. And Jeremy will be doing molecular studies on the flesh, the living flesh of these, so he can classify them. And he'll probably end up being one of the world's experts on black corals. But it really helps to know the zones that they appear in, get a sense of the trends. And now this is our fourth dive, and the trends are definitely starting to become more obvious. So this zone we're in, we've seen black corals at similar depths on the previous dives.
Jeremy's online. He's asking if at some point we can zoom in on one of those black corals next time we find a nice one. We've got Jeremy, an ID for that for us. Next to it, there was a thing looking like a rock, and that was a. We don't need to go back to it, but it's one of these rock sponges, and they look like rocks, and they physically act like rocks. They feel like rocks. They've got the same density as rocks, and they're made of glass. But these guys form glass spicules, which are like interlocking fingers of a hand, and they do that in such a dense format that it is like a rock, and you can't cut it with a knife or anything. It's the same as if you're trying to cut a rock on the ground with one. So, another beautiful black coral.
Yeah, I remember we collected some in August last year when we did that big geological expedition to the Tasmanian seamounts. And the first time we brought them up, we were really confused as to what we're looking at. It felt like bone. When you've actually picked up like an animal's bone, it was that dense. It was heavy too, but it was heavy mainly because there was so much water inside. It was almost locked inside. It wasn't until it dried out that it became a lot lighter. But absolutely, you're right. It was all it was extremely dense silica needles, but about the thickness of your finger. So it looked like almost like a dinosaur bone.
Yeah. That's cool. It's like a sclerotinium there with its tentacles out. And that's a rock sponge, that round, that spherical one next to it as well. So there's one of those rock sponges we're talking about. Yeah, I'm no good at my solitary coral, so I can't help you on that, sorry. I've got some polychaetes and another black coral. Well, Jeremy's identified it. Stickopathes, and says it's got its extended tentacles. It is hungry, he said.
Thanks, Jeremy. And really long too. I mean, what would you guess? Maybe a couple of meters, or certainly over a meter, I would think.
Yeah, getting close to 2 meters, that one, I guess. Yeah. Couple more rock sponges. Yeah. Oh wow, look at that beautiful coral. Oops, touch the bottom there. Looks like could be a massive stylaster. Great looking specimen. It's like half a meter across, that one. It's huge. That's such a big one. Interesting looking things there. Not sure what they are from this angle. Top one looks looks like a glass sponge. Going back to the area, it looks like it's all solid limestone again. I think it looks like lots of polychaete worm tunnels in there. Crayfish. That's what I've learnt today. Good to learn new things every day.
Hey Merrick, Deb's here. I was just wondering if you have a microphone that you're using, could you put it a little bit closer to you or something? You sound pretty far away to us all of a sudden.
Yeah, all right. It's one of those fixed ones.
Okay.
It's
No,
on
it's
my
okay.
headpiece, so I can't do much about it, unfortunately. I'll try and turn it up a bit, see if that makes any difference. No, it's maxed out. Is
Okay.
that better if I hold it there? Is that better?
Yeah, it's better. You're a little bit louder, yeah. There are times that it just sounds like you're kind of really far away in a room.
Okay.
Yeah.
Yeah, I know. I've heard other people talking over the top of me, so I've seen no one heard what I was saying.
Yeah.
Okay, I'll hold it there. Yeah.
Cheers, thanks. So it looks like we're just starting to come up to the base of the main wall here, and get as we're getting shallower, starting to get more vertical.
Nice.
So for those of you at home, the pilots are saying the current is going pretty strong from north-south. Does it seem like it's increasing from when we were deeper? Pretty much the same. Mm-hmm. Ah, yes. It's pulling.
The umbilical's going down to south. It's relatively tight, 69, and launch quite sharply after this. So.
it's interesting here. We've got a vertical face, and I thought I'd be seeing more sessile organisms attached to it, but maybe this get bashed off too close to the edge here.
Yeah, it's interesting. We're just starting to be at the base of that the next sort of vertical face up to the actual top of the reef. So maybe with a little more current or something, it's not as rough as well. It looks kind of like smoother surface. There are a few little corals there tucked in and around.
Yeah, that's right. It's all minute stuff. Yeah.
Yeah, sure. Just going to put up an inset camera for those of you at home and show you a little bit what this wall face looks like that we're climbing up. You can see the downward looking camera on the ROV in between the arms and the tool tray that typically comes out. So we are climbing a absolute vertical wall here.
Yeah, you can start to see a bit more life occurring where there's enough, a bit more overhang for them to shelter in, I think.
Yeah, Merrick, I'll change your camera real quick so you can see what I'm talking about at home. But
yeah, that's right. Okay. It's on our screens as well.
oh, you can see it. Yeah.
Oh, yeah.
There you go.
Yeah. Lovely, beautiful. These guys are doing a great job not running into the wall there.
And I've just put up, for those of you at home, the vehicle has a scanning sonar, and so you can see this wall face is the sharper, brighter return in front of us. So pilots have a sonar that kind of gives them an idea of how far away the wall face is as they're moving the vehicle around.
So looking at that sonar scan, it's got like a really bright band close in and a further out band. So if they're close in one part of the ROV, or is that the wall right in front of them?
The wall is the brighter band. Probably the second return it's probably just an echo because they're so close to it.
Yeah, yeah. It's great to see all these corals everywhere. Oh, I get really excited. So I want to go and grab one and I want to look at it really closely up under the microscope and see what it is. It's so tantalizing in front of you.
It does look like a fish that just went by.
Yeah. Almost looked like it was swimming vertically and being blown sideways by the current.
Interesting little cubby hole. It's like the current kind of. Yeah, it's like a little shell rubble inside the little cavern. It's like a hermit crab of some sort. And it's in the multibeam data, Russ, it's like 40 on top of that. So when it gets way up to the top, it's about 40 meters when it starts to bend over the top of the reef.
So are you saying we're effectively inside an overhanging cave, but obviously hundreds of meters above us?
Sorry, ask that question again, Merrick.
No, you said there's 40 above us. Does that mean we're sort of like inside the reef, if you like, under the overhang of the reef?
Yeah, you know, we're basically the edge of where the LiDAR ends and our bathymetry meets it, where it's about 40 meters directly above us, not like 40 meters below the surface of the water. So we are currently at 333 meters working up. So if we go up and have a 40-meter depth, we should be seeing sort of the edge of the reef there.
Yeah.
According to the multibeam and where the LiDAR meets, so we can't get any higher with our sonar without having, you know, a sideward looking sonar.
Yeah.
For those of you at home, I promised an outside view when we got closer to the reef, and we're pretty close to the reef right now. So let me see if we can. I'll actually zoom out so you can see part of the ship. So that's our view out off the stern of the ship right now. And so you can see the breaking waves aren't too far away. And if I pan behind us. So the ship and the vehicle are running in tandem parallel to each other as we're working north, and north brings us in tucked into this reef. And so you can see that bit where there is a lighter color blue and waves crashing over it is the top of the reef there. So the goal, hopefully, on this dive is to get all the way up so we see that top edge as we're coming out of the water. Oops. So somebody at home asked about a camera pitch angle. I can't show that to you, but I can show you the camera real briefly in this shot. So if you look in the inset, you can see the angle that the camera is looking up a little bit. So that 4K science camera is tipped up, pointing kind of in front of us and up a bit. So for the viewers at home, I just put up the Copilot display overlay so you can see the ship and the ROV in relation to each other. The color scale, the white is shallow and orange is deeper. So we are currently going up a pretty steep wall, as you can see in your video. And we are headed up for that last waypoint, which will bring us up to the top part of the reef. So we are looking at the side of the reef here, where we're a bit on a part that juts out, and also the area where that slump came down. So we're kind of seeing a multi-interface area here.
I'm going to have to head off now. My 1-year-old's just woken up. So.
Great. Thanks, Merrick, for joining us.
Everyone.
Appreciate it.
Thank you, pilots. Thank you, Deb. All right, enjoy the rest of the dive.
Thanks. Hi everybody. You have not lost audio. We are science team offshore are taking a bit of a break, but you still have us here on the ship. So if you have questions right now in the control room, we have Ben, Russ, Chris, myself, and Carl. We are currently at 271 meters. The temperature now is at 19.4 degrees Celsius. We're going to take a moment here, and we are currently climbing the very sheer side wall face of this reef. We are diving on the east coast of Australia on the west side of South Flinders Reef. We are making our way up to the surface here slowly along this wall face. So as we get farther up in the water column, we are starting to see more coral and more life, which is good. Yeah, so one of our Facebook viewers, Tim, says, it is beyond me how anyone would not be riveted knowing we're among the first human eyes in history to see this part of our home planet. This is, I think we are the first group to dive as deep as we did, 1,000 meters up to the surface on this particular reef. Many of these reefs out here have not been explored in the deeper areas. I think there are quite a few people in Australia who come out and do some scuba diving. But ROV SuBastian is able to dive to 4,500 meters. This whole plateau area is not much deeper than 1,000 meters, so we started about 1,000 and work our way up to the top of the reef as close as we can get. We're fortunate today. The weather is exceptionally nice. It's flat, calm, and light breeze, and so we're able to tuck ourselves in and get pretty close to the reef today. So the pilots and the bridge team are working together to maneuver the ship and the vehicle as we come up this wall. Looks like a squat lobster or something, or maybe a crab tucked in a little hidey hole. We've seen a lot of these sort of crevices in the side of the wall, and squat lobsters taking shelter. Or a spiny lobster. If we weren't having pizza for dinner, Russ, maybe we could, no. Just joking. We're not sampling. Lobster pizza. Is that a good thing? Lobster and cheese on bread. Sounds good.
Sauces in there.
Mmm. Cheesy sauce. There was a question if we have seen any nautilus today. We've seen a couple of shells, but no live nautilus. Not this dive.
Not this current.
Yeah, not in this current. It's a pretty strong current right now. The pilots are being pulled by the current quite a bit now as we get higher and higher. Just want to say thank you to everybody who's watching on YouTube and Facebook. Schmidt Ocean Institute, Research Vessel Falkor, and ROV SuBastian. We are just making our last couple hundred meters of descent up out along the side of South Flinders Reef. As you can see in the inset, we are about halfway or so up this wall face, making our way up to the surface. Temperature for those who are interested is now up to 20 degrees, 20.5 degrees Celsius. Fish has stuck his nose in a hole. I was just asking the pilots if they could zoom in on what looked like little blue specks, but they're actually quite like a dark purple, and our guess is maybe they are original bases to some coral. Maybe Jeremy, you can answer that, but it looks like maybe where a coral was once attached and it's broken off, died, fallen away. Temperature is up to 22 degrees Celsius. I don't know if any of you caught there was a bit of a shimmer in that in the water, and we saw it go from 20 to 21.5 as we went through it. So definitely temperature climbing and a lot more coral. So we're just coming near to the end of our dive, and we have this giant coral here. I was going to show you some Google Earth overview, but we have this beautiful coral. Looks like Tom's come back. 1 second, everybody. We're going to get Dr. Tom Bridge on the line. Tom, can you hear us? Hi, Tom. Are you there? Hi, Tom. Are you there? Looks like Tom's come back.
Yeah, I'm here.
Bridge on the line, Tom. Understand audio.
Yeah,
There you go.
I'm just dealing with kids for a sec, so I'll unmute in a second.
Yeah, sure.
Yeah, I'm here. Yeah, hi. I'll be a few minutes.
Okay, so everybody at home, we've put a inset map up of Google Earth, and it can give you a little bit of overview of where we are. So I'm going to zoom way out, spin us north up. So we are just off the east side of northeast of Australia, just off of Cairns, and we are working on the Queensland Plateau, and we are currently on the South Flinders Reef. And you can see in the Google Earth image, you can actually see sort of into that lagoon. We are just outside of it on this face here with this dive track. You can see where we've come up through and along the wall. And we are at 278 meters, temperature is 22.5 degrees, and we are making our way up to the surface. This is Schmidt Ocean Institute, research vessel Falkor, and ROV SuBastian.
Okay, Debs, I'm here now. Are you able to hear me?
Yeah, thanks, Tom. Sorry about that. Didn't mean to add you too early.
No, that's all right. Just trying to deal with 4-year-old and a 9-month-old. The 4-year-old's very interested actually in a lot of this stuff.
Great.
The 9-year-old's just wild, so not very. But yeah, look, it's getting really interesting. We're really getting into the Mesophotic. I guess for most people more familiar octocorals mainly, or most of these, at least the conspicuous ones. There's things like Dendronepthere and Chironepthere, probably some Stylastrids on those walls as well. So yeah, look, it's really interesting to see. Some black corals too, some Antikytherians. So my student Jeremy would be very excited. Spent a lot of time watching the videos from the Ningaloo Canyon as well.
Great. Yeah, I believe Jeremy's watching on Facebook. He was making some comments earlier, so I do believe he's been on. So, Tom, can you just introduce yourself real quick? We might have some different viewers from the last time you were here. If you can just introduce yourself and your affiliation and a little bit about what we're seeing.
Yeah, sure. So I'm Dr. Tom Bridge. I'm Senior Curator of Corals at the Queensland Museum, based in Townsville, and also at the Centre of Excellence for Coral Reef Studies at James Cook University. So I do research on Mesophotic coral reefs.
Hi Tom, Rob Beeman here. Can you hear me?
Robert, Tom's audio just dropped out real quick. There he is.
Yeah, I'll use it as there was some background noise. So I've worked for over 10 years now on Mesophotic reefs. So we're starting to get into the depth range of stuff that I'm a little bit more familiar with. So a lot of these critters here are somewhat familiar from the research I was doing in my PhD. So you said mainly octocorals, most of these things. There's some really beautiful ones here. I know a few people that are getting very excited right now and very disappointed that we're not collecting anything. But that's all right. We'll do that on the next trip. There is some, probably also the small brown patches of sponges. We're starting to see some crustose coralline algae as well. So starting to see, I guess, just enough, probably just enough light that we're starting to be able to see photosynthesis occurring and photosynthetic organisms as well. no corals and things yet, but we are getting to the depth where we might start seeing some corals. I think the deepest, at least by corals we mean photosynthetic corals, have ever been found is around about 170 metres. So hopefully we might be able to see something like that around here. That'd be really good. Definitely be by far the deepest record for Australia, so we'll see. There's obviously lots of other types of hard corals that don't require any sunlight, and they can live into very deep water, thousands of metres deep, so much deeper than this. But yeah, most of the dominant benthos here is octocorals. Also, I can see there's a few other things. There's a thing that we used to call a Dr. Zeus thing on my during my PhD, some very sort of squiggly lines into zoanthid. So a number of different types of cnidarians, but also some sponges and things like that in the view, which is really interesting. Some of these beautiful big gorgonians, which are very characteristic of this sort of habitat. They really dominate these sort of environments throughout most of the Pacific and probably the Indian Ocean as well. Not so much in the Caribbean and the Atlantic. Tend to get more other things, but these big gorgonians are very, very dominant creatures in this sort of habitat. So they're filter feeders that don't require any sunlight. Sometimes they host a lot of other animals as well. So things like pygmy seahorses and things. If we got really, really close, we might see things like that as well, which would be really cool. But yeah, they're not easy to see.
So, Tom, what sort of hard coral species might we find? What's the kind of at this lowest depth? What's the sort of species that you first think that we'll see? Is it this Leptosperus that you talked about earlier?
Yeah, indeed. So there's a genus Leptosperus that is completely dominant in the Mesophotic zone. It's by far the most common down there, and it's sort of unusual in that a lot of the species are specialised to deep water, or sometimes in shallow but more shaded habitats. So if you do see them on shallow reefs, it's often in caves or overhangs or shaded by something else. And so, yeah, Leptocerus is definitely the most common, but there are a few others down there. We see some of the lobophiliid species, so Mycedium and Echinophilia and things like that as well. These big, fleshy, quite spiny species. They look a little different to how a lot of them look in the shallow. They're very flat and tend to be relatively small and encrusting at these sorts of depths because there isn't a lot of light, so they're a bit constrained in the shapes that they grow in. In the shallower areas, they'll often form plates or whorls or tiers, whereas here they're often generally just sort of encrusting on the rock. But yeah, certainly very dominated by gorgonians and a few different types of black corals at the moment, and Antipotherians. You might be missing the black corals in that they're not black. They're called black corals because their skeleton is black, but usually they're covered in, their tissue is often quite brightly coloured. So some of these sort of corkscrew wire things that you're seeing going on, seeing out there, very long corkscrew things, are actually types of black corals. So and there's a few others down there.
Yeah, we saw lots earlier.
Yeah, okay. They're quite interesting actually.
That zone around 350 metres.
Yeah, okay. Yeah, cool. Look, they're a pretty interesting group. I said I've got a student working on them at the moment. We used to think they often look like gorgonians. They're often confused with gorgonians, but they are actually, we know now they're hexacorals, so they're related more closely to hard corals than they are to the gorgonians. But it can be a bit confusing because there is whipped gorgonians as well, so they do look superficially a little bit more like gorgonians, but more closely related to hard corals. this is a good example of why we need to collect specimens, because all of this has been worked out by using molecular techniques, molecular phylogenetics. So rather than just being able to tell the morphology, a lot of times we have species that look quite similar because they've evolved, very similar strategies to exist in the same environment. So, the selected pressures at living in a particular habitat are obviously the same no matter what organism you are. So a lot of the time there's only a certain number of ways to do a particular thing. And so you do get this we call convergence, where different groups sort of evolve the same strategies for dealing with particular habitat. So there's a lot of good examples of that, but whether this is the case here, but there's certainly a lot of these black corals do look quite similar to some of these gorgonians, but as we now know, they're only very, very distantly related.
And Tom, these sort of long, almost strand-like animals on the wall, would they be sponges, perhaps?
Yeah, it's quite likely. So I'm trying to have a look at the YouTube screen because it's a lot clearer to try and get a better idea of what things are. But we're just a little bit out of sync here. So okay, yeah, if we can zoom in a little bit, that would be helpful. Possible as well. There's a number of different octocorals of various types that can take on that sort of morphology again. So things like...
Tom, we're just zooming in now, so you should start seeing that. If you're watching on YouTube, you should start seeing it in about 20 seconds or so.
Yeah, excellent. Thanks very much. Yeah, sorry, I have got them both on the in front of me, but not really clear enough in the Zoom to see it. So once we get in,
yeah, it looks like those sort of disc-like dark brown objects. Is that crustose algae or perhaps zoanthids? What do you think?
It's going to be hard to tell. Have to come back on our sampling trip. It definitely, as you can see, a lot of gorgonians, things like that there, spirastrid corals. We're starting to see as well, it's very obvious, I guess, how much more life there is even at the sort of smaller scale. The wall is very colourful compared to half an hour or an hour ago, and we're down a little deeper. So there probably is lots of sponges, as you say, Rob, things like ascidians and things. The brown encrusting one is really numeric, but yeah, I'd say most likely a sponge. There's certainly some other things down there as well.
Yeah, really, the wall is nearly 100% covered with something living in now. That wasn't the case just not so long ago, an hour ago. It's definitely jumped up. I'm curious as to when we're going to start seeing living halomedas, green algae. If you remember, Tom, the voyage we did back 10 years or so ago, we found it's like curtains of living halimeda down around 120 metre mark. I'm not sure if we'll get up that high with this ROV, but be very curious because we've seen a lot of these halimeda flakes, the dead halimeda flakes, further down in the depths, and they look like little white cornflakes, but it's come from algae rather than coral.
Hey guys, if I could jump in here real quick, the pilots were going to turn the lights off to kind of give you an idea of what our ambient light is without the vehicle lights on. So I'm going to do a picture-in-picture for you guys on Zoom. You're not going to see it, but for people at home, you now see our sit camera and our science camera behind it. And if the pilots go ahead and turn the lights off, you can see. Yep. there is some light that you can actually see from the surface, so we are quite shallow. It's 150 meters now. Temperature's 23 degrees Celsius, and we are trying to come up to the surface.
This is sort of the deepest depth that divers tend to reach, at least for science. It's about 150 meters, using special gear like closed circuit rebreathers and mixed gas diving. You can actually dive to about 150 meters. There's a handful of scientists in the world doing that. People studying fish and gorgonians mainly at the moment. It's very specialised diving, and it's quite dangerous potentially, so you really got to know what you're doing. To spend about 15 minutes down at 150 metres requires about 4 to 6 hours generally of decompression, so to get back up to the surface, breathing different mixes of gases and stuff like that. So it's not an easy thing to do, but it does provide a really interesting opportunity for people to actually go down and view these habitats up close, which is really interesting. You can starting to see a lot more of these familiar octocorals here. This bright orange. Some of these bright orange ones are look like pyronephia. Also looks like some dendronephia around, which are a number of others as well. Most of the time with these octocorals, at least at my level, what we need to do is collect them and look at what's called the sclerites, these little sort of skeletal bundles that they're made of. Even though they're called soft corals, they don't have a hard skeleton like a hard coral, but they do have these little spicules. And the gorgonians, people call gorgonians, have a skeleton, or not a skeleton, but sort of an axis made of stuff called gorgonin. And so by looking at this under the microscope is the best way of identifying what some of these are. So you can see some of these soft corals. If you do touch them, they look very soft, but they are kind of spiky when you touch particularly the polyps. And get really close, you'll be able to see these little sclerite spicules, and each genus and species has a slightly different shape. So you can start to use these to see what's going on in terms of the different species and genera down there.
Tom, I've been struck by how much movement, water movement is around here. We haven't seen this before. I mean, the depths on all of the dives we've done now, seemed to be very calm. But up here in the Mesophotic zone, there's quite a decent current streaming past. You can see the direction. I think it's sort of from left to right. But clearly that's what's happening around these reefs. Of course, all soft corals need that. A good current around it to bring food to them because they're stuck on the wall. But all movement's relative, and as long as you've got a good current moving around, it's bringing lots of food in. So that's obviously something that's really a big part of the environment here, is that strong current flow.
Yeah, Rob, it's our ADCP sonars, acoustic Doppler current profilers, are showing about 2 knots, I think, 2 to 3 knots of current. Yeah, 2 knots, and Russ asked me to send, so you see at home now, the sit camera, so you can see the current is much stronger there going around this wall.
Yeah, absolutely.
Yeah, so 2 knots is a decent current. You'd really struggle to swim against that yourself as a human. But fascinating to know this. This is all part of trying to understand the environment on the Coral Sea Marine Park, which is the aim of this condition. We haven't spent very little time at all in the deeper parts. Certainly the shallow coral reefs are much better studied, but the only things that can get down to here are either shallow ROVs from above, or what we're doing with the Falkor, the deep ROV. But this is really quite a sort of unique, a frontier zone is the Mesophotic zone. I think you'd agree, Tom. It's where a lot of coral people are really starting to push down to, because our technology allows us to get down.
Absolutely. Can we zoom in with the lights on some of those overhangs? They're really interesting places for octocorals. You can see us coming up to these overhangs here. We've seen some absolutely beautiful, really beautiful overhangs like this, where you get these beautifully coloured soft corals hanging down underneath these things where there is the current. As you say, Rob, this current is absolutely critical for these things. Everyone that's been diving in these areas with renowned for strong currents will know that a lot of these brightly coloured soft corals, they occur in places of high current. That current can come and go depending on tides and things like that. So it's not going to be rough all the time, but if there is a lot of them like this, really dense coverage of these, it's a good indication that there is a lot of current at least some of the time. So it's really interesting to see this sort of habitat we've seen before at Osprey. There's a dive site, Deep Arcade, which is about 70 to 80 metres depth. That looks a lot like this. So it's very interesting to see this sort of environment here at Flinders Reef.
Guys, Jody had a question.
Yeah, these caves are...
Sorry, Jody just popped in and said he had a question about whether he thought they were wave-cut notches.
I was just about to mention that. So what we've seen previously at Osprey Reef is around this 130, 110 metre mark, that there are a whole series of caves. Now, we saw that at Osprey Reef, and the question is, do we see them here? Now, it looks like we're starting to see some overhangs and some perhaps wave-cut platforms, and this might suggest that where sea levels were about 20,000 years ago, last ice age, sea levels were 120 metres lower than where they currently are. Now we're just into that kind of sweet spot, and we'd like to see just more evidence of caves and things. So it has an interesting geological origin, perhaps, these caves, but it also is a great habitat for all of these soft corals that Tom's talking about.
Great. And just for you, Rob, we're at 127 meters and the temperature is 23.8 degrees Celsius.
We're going to try and find corals. What we'll often find as well, they should start to really potentially be seen on this, on the top of these notches, like just as you come out. Obviously, I think we were talking a bit earlier about, we're starting to see some of these plating coralline algae, those coralline algae and stuff. That big blue thing. So yeah, potentially, once you get onto where it's flat, where the corals can maximise the amount of light that they'll get, probably the sort of depth I'd start to see, expect starting to see corals in this sort of a habitat.
Yeah, thanks, Tom. Would you agree that wave cut, well, those caves that we saw earlier, they were quite distinct. The first time we really saw that. Now there seems to be lots of ledges, but I think that first time that we stopped and had a look, they were the first really obvious caves around about this depth. So that's quite significant, I think, geologically.
Yeah, absolutely. Certainly, it's something. It coincides, I guess, with the depths that you would expect to see notches from the lower sea levels, from the glacial maximum and things like that. It is interesting that these notches seem to be such dominant I guess it's so important for these octocorals. We're starting to see a few things, these big orange anella fans and things like that as well, coming into view now.
Hey guys, just for your information at home and for Rob and Tom and everybody, the pilots just let me know that we can come up to about 100 meters or so. At these depths, the vehicle gets quite warm, and so they're going to have to recover at some point here. So we'll get up to about 100 meters, so about 12 more meters, and then we will, that's about as high as we can go.
Yeah, thanks, Deb, and our pilots Ben, Russell, and Chris done a fantastic job. This has been a really great transect. It's the first time we've come so far up into the water column. It's really been amazingly beautiful to watch. So appreciate you've gone to their effort to get us up into these steps.
Russ says no problem. You can buy him a beer when we can go on land. Chris drank whiskey.
Sorry, in the screen here.
Sorry, go ahead, Tom.
There's a coral. I think we've just gone above it, so just below these fans in the zoom screen.
Tom was looking at a coral just below the fans.
Go back down.
Is it like a light pink color?
Yeah, there it is. Okay,
yep.
So it's brown, so zoom in.
Like that up there.
And then to the left a little. A little more.
So it's the pinkish color, the pink color one that's sort of fan-like?
No, here it is. It's just coming into view now on the zoom.
Yeah, maybe that.
So I've seen it. See it now in the bottom left. It's light brown with some dark brown mottling colour.
That one.
The one. Okay, excellent. Cool. So that looks. I'll have a look on the big screen in a minute, but probably one of these Leptoceras. So that's interesting. That's probably at least the deepest coral I've seen here. Yep. Leptoceras. Excellent. I mean, that's the sort of coral we'd expect to see here. So, yeah. Oh, I wish we could collect it.
And I'll just throw in a few bits for the algae. That round ball there, that's Valonia ventricosa. It's a sailor's eyeball. And there was some living halimeda too. That was really good to see. That's a green algae. It sort of forms these fronds. And when they're calcareous, when they die, they break off and form these sort of cornflake-sized flakes, which just form part of the sediment too. So it was great. If you could do a sort of one more close view, I know we're getting to the end of the dive, but if you could just zoom in a little bit closer to the substrate, there's quite a lot of detail close in. It'd be good to just have one more look at that before we call quits on the dive. Thank you. Yeah, so lots of algae coming in. Just they're still very bright here. There we go. Thank you. Okay, we can just scan up. Okay, so it's a real mix of soft corals, sponges, those white flakes that's kind of sitting there, probably almost like fingernail size. Most of that is algae, halimeda algae, and it forms these sort of fronds, maybe 10 centimeters off the seafloor when they're live. They're green, and when they die, they break up, and that's what most of the sediment is that we're looking at now. This is halimeda. And there's some living halimeda. This is the green, just on the left-hand side, sort of waving in the breeze there. And yeah, so they're a big part of the substrate here. The living substrate is this green algae. And we have a big expedition coming up in the Great Barrier Reef, hopefully in the next year, to go and study these. They make these great big piles, sort of almost deep like reefs, just built up. They're called bioherns. It's a geological term for reef-like structure that's not made of coral. So just to repeat, this is algae.
There's certainly a huge amount of life here. See some, looks like some benthic forams as well down there. Foraminifera, meter. But yeah, look, you know, and it's a lot of this is probably attributable to this current. You know, it is interesting that we're seeing so much current in this particular spot. Yeah, especially with all these gorgonians and all these filter feeders here in this community. I guess this is what you'd expect to some degree. You expect to see a lot
Do
of...
you remember that paper we wrote together looking at the deepest corals, and we talked about like these big sort of like fronds of halimeda hanging down around 120 meters. That was up at Holmes Reef, but we're seeing the same thing here at Flinders Reef. So this seems to be a fairly typical pattern in the Coral Sea Marine Park. So you know, these long vertical transects are very, very useful for us.
Absolutely, some beautiful big gorgonians on the edges of the walls here, and the soft corals. Oh, there's some interesting fish. There's people that love fish.
Hi everybody, I think we just lost our scientists. I'm just going to try to get them back. Hi everybody at home, thanks so much for joining us. This is Schmidt Ocean Institute, Research Vessel Falkor, and ROV SuBastian. We thank you very much for joining us today. We are having to go deeper with the ROV because it gets quite warm for the vehicle up here. So we just appreciate you joining us. We're going to be ending our live feed here momentarily. But we just wanted to say thank you very much for joining us, and we will let you know when our next ROV dive is. So stay tuned to Schmidt Ocean Institute YouTube and Facebook, as well as schmidtocean.org. Hi, Rob. I think you're back
And,
with
to all
me.
viewers, yes, I just wanted to say thank you very much to everyone watching. It's been a real joy to see go from the depths. We started at about 1,000 metres early this morning, and we've travelled up to around 100 metres. So we've really captured that whole deep water and Mesophotic. So it's been really exciting. It's also been great to have some of the other principal investigators join us. Dr. Jodie Webster from University of Sydney, Dr. Merrick Eakins from Queensland Museum, and Dr. Tom Bridge from Museum of Tropical Queensland, based in Townsville. The plan is over the next few weeks is we'll continue to run ROV dives, perhaps every 2 or 3 times a week. We'll be at different parts of the Queensland Plateau. There are these 30 large atolls, mostly doing multibeam mapping, and we will find interesting places to run these long video transects up them. But for now, thank you very much. This is Robin Beeman from James Cook University in Cairns.
Great. Thanks very much, Rob. And thanks everybody at home.